Yo, 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 it's your boy, DJ Slow Grow, aka the boy, the man, the dude, the dog, the nickety neck, DJ Slow Grow, here with day 3 of Kotlin, iOS, development. Day 2, there's not a video. I received what I would call an emotionally taxing communication within the middle of that video, and didn't wasn't good enough for a video. This is not like all killer, no filler sort of video, but it should be of some quality. So if this just turns out into just utter junk, I won't release it. And some of it will be tedious. It's 12:12. I started the video at 12:10. The time limit on a YouTube video is 12 hours. That's the plan. The plan is 12 hours of coding. And I've got my phone on, but right now I'm not going to take job recruiter calls because they're not going anywhere right now. I'm trying to fix that, I suppose, with this Android endeavor. But yeah, I mean, it's just, I would get emotionally invested in the company and be, interested, checking out the company website and, looking up things about the people at the company, and then they'll just say, we've decided to move forward with other candidates. So I'm trying to keep that emotional investment down. So right now it's, the nose knows no investment. So this is not emotion. This is logic, just logic. And no, I'm not fuming with anger. Unless you're talking about preventing people's right to a vasectomy. So you should have that right. But yeah, so yesterday, this is the goal. So the goal is to have this stereoscopic button work, to be stereoscopic 3D with all this frizz frazz, razzle dazzle, razzmatazz, multipass rendering, Android and iOS. It's funny, I'm dyslexic. I pointed to the wrong one. iOS here and Android here. Obviously, they're not at the same stage. And what's exciting is I'm new to Kotlin. This is my second day of coding in Kotlin. So I had one tiny partial day. I don't count that one. I was mostly struggling with logcat and getting things set up and getting it to not crash immediately. And it took me a while to understand what the whole scenario with logcat was. I was like, oh man, I can't see my prints, dude. But yeah, so this intro has gone on too long already. We're at like the 4-minute mark. So what can get done today? I solved off of the video one of the bigger steps, which is this kind of like 2-texture thing in OpenGL, and then also getting the coordinates for this 3D globe. So you can see I've got the 3D globe actually running on the Android one as well. So there's just been some restructuring and a lot of finagling. It took me too long to cross some of those hurdles. But today, there's going to be some tough hurdles. But I think today this was the big remaining question in my head, and kudos to ChatGPT, who helped largely with this. It took a lot of attempts with querying ChatGPT, but it eventually spit out pieces of what I needed, not the whole shebang. So with converting code, it spits out the whole shebang. It's great at converting code, like convert this from C to Swift. I wish I had that tool years ago. It would have saved me hundreds of hours. I'm using it religiously now. Convert this file to Swift, convert this file to Kotlin, and it does great for that. But yeah, so today I want to get started with the globe and the globe on iOS, and take a few steps forward there, and then maybe this is mixed platform development, iOS and Android. So it's just gonna be a battle against ugliness here. So the ugliness that we first must confront, or not must, but we're choosing to first confront in this video, is the stereoscopic, which makes not for a great demo on video unless you got the glasses, which I do got the glasses. So holler if you hear me, my 3D crowd, my stereoscopic crowd, because I am stereo boy in a mono. I'm a stereo boy in a mono world. But yeah, let's go. Let's poke at something, anything. Let's get something rolling. This is how the development process works. That was our stand-up meeting. Now it's heads down and coding. So I gotta pick a task, and as I said, I want it to be about the stereoscopic. So to get it working in stereoscopic, interestingly, I've already tried something that didn't work. I have a little bit of a clue as to what I want to start trying, but we need to know like how stereoscoped each pixel should be. So my first step is to get to the point, and I think it's gonna end up being more struggling with the math than I really want, but getting to the point where like the nearest pixel to us is like the most stereoscoped, and we can just do that with a simple color for now. So that's gonna be my approach, to get a colored globe. And I'm in iOS and I'm doing Metal code right now. Metal iOS. And this uses Swift UI. Obviously Swift UI is not like the main thing of the app, but the shell is Swift UI. We've got a whole little Z-stack going on here, pickers and stuff. So those things are pickers. And I hope to fight through that on Android, getting a picker to show up. But yeah, so we got Earth scene. I gotta remember for myself, Earth scene. And the Earth scene has like a Earth object of some sort. I don't think we need these prints. So there, I've coded my first line or anti-line. And just in Draw 3D, this function we got all this lighting stuff going on. So it's gonna not be about lighting in stereoscopic to start, but we do want to get it working with stereoscopic. You know, let's project manage. So real quick, let's write down the priorities for the day. So these are the daily priorities. So one is gonna be proofing per color stereoscopic ability of the globe based on which pixel is the closest to the user's eye user's eye. And then 2 is going to be getting the whole damn stereoscopic render working for at least one pipeline state on iOS. So the ETA, let's put in ETA. This should take like, I'm gonna say this first one has an ETA of between 1 to 3 hours. For 2, I'm gonna say the ETA is also 1 to 3 hours. Then 3, we got to get a little bit farther with the Android one too. So with Android, I guess it would be getting the bloom filter to work. So just, I guess, setting up any kind of bloom filter, setting up Gaussian blur / bloom, linking up the pipeline. And this honestly is like an ETA, 5 to 6 hours perhaps. I just feel like there's going to be a lot more issues there. So that's enough. So this is our management priorities. Daily Monday. And this should get us the ball rolling. So yeah, we can kill this app. We don't need it hogging up processing power. So in this draw 3D, I'm using like this crazy nightlight buffer thing. So instead of that, I want to switch to colored 3D vertices. Yes, colored 3D vertices. And I don't even know if like I've built these objects yet or not, but I do know that I have the pipeline states in metal. So I'm just gonna call this stereo setup test buffer, and it should be like shape 3D colored vertex. Okay, I do have that shape 3D colored vertex. So first, let's get that vertex loaded up. So there's a lot going on here with some history that are not part of this video series, but essentially it's writing the vertices of this globe into these buffers. And I pretty much already have these variables floating around, the X, Y, and Z positions. So it's just going to be reusing one of these buffers. And in fact, it could just be reusing this texture triangle bloom buffer, and instead replacing it with this buffer. So this whole buffer is going to become this buffer, and these are now shape 3D colored vertex. And these should take an RGBA. Let's make them all 1. We could make a constructor that does that for us. but it's not the hardest thing to type for right now. So there we go, 111. I won't bother putting it onto good lines. This is going away. This is an intermediate step. So we loaded up the index buffer and we loaded up the vertex buffer, which I have condensed into this one object. You saw me build a similar object on Android, although it is quite honestly quite different. These are resizable buffers. The Android ones are static buffers. These ones have been through a bit more of what I would call the ringer. I have this update stereo function. I'm just gonna delete everything in it because nothing in it works. So there we go. I'm just gonna print the value. Update stereo to rotation. And really, this is this should say radians, and then this can be like math.degrees from radians. We'll fix that later where it's being called, but yeah, it's radians. It isn't something else. Then we can just comment out this bad boy, nightlight buffer. And the bad boy we want to have get involved with our situation is going to be the bad boy here, this guy. So, this might be enough to get the render going, but we have to be careful because this render takes as an argument a pipeline state. So I think the earth itself is choosing the pipeline state. So we just have to not use that nightlight buffer, and instead we will use like shape node. It's going to be something colored indexed 3D. No blending is fine. That's probably the one we want to use. And then somewhere, yeah, this just has to be, say, radians. Radians. And let's make it even say radians here too. Update stereo with radians. Just to decipher between degrees and radians. I won't make this say earth rotation radians, but we could say earth rotation radians. I've used degrees and radians enough times to, hey, it doesn't work. Nothing shows up. I think the problem is needing to load this mamma-jamma. So it needs just a reference to, uh-oh, that's not the one. Stereo setup test buffer, is that the one? Okay, so this is an indexed sprite buffer. We gotta be careful. So there is indexed sprite buffer, but what we want is indexed shape buffer. Doesn't take a texture, so we gotta be real careful there. So we want an indexed shape buffer. And the only little difference here is going to be that we load without a texture. And this again is the beauty of these modern languages, is the reusability here. Like, this thing can work with any uniform type, any node type. So it's a tremendously powerful tool. I haven't figured out how to get rid of these warnings, but we're always using structs. The warnings are because these could be structs or classes. So I wish there was a way to say this protocol is a strictly struct protocol. There's not a way to say that. But yeah, anyway, so let's run it again. I can't tell if it, no, it didn't. Oh, it's freezing, it's frozen. A little bit hard to tell, but it worked. So the buffer indices are all white. So if we, like, for example, made one of these a different color, we should see some of the vertices showing up as a different color. Yeah. So that's our globe. It's just a bunch of triangle strips. They go boom, 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 boom from the top down. Now this says, I predicted this was gonna take 1 to 3 hours, because right now there's just a math problem, and maybe it'll take less time, but I'm like I'm a bit nervous because I don't know how to do this. So we gotta like loop through all these vertices. So like I think we can have this same loop and even the same XYZ blah blah blah. So let's just grab all this junk. And this is gonna be super easy to see with these colors, I think. That was the mistake I made before. So we're learning from a mistake I made before, which was that I was trying to update something and I could not visually see like the thing I was trying to see visually. So visuals are key. So we just want to like unwrap Earth model data. And you might find out that I'm like way faster in typing Swift code. So if let Earth model data equal Earth model data, then blah, we do blah. Otherwise, nah, nah. And we're really, you know, maybe we're concerned about the normals instead of the positions. That's one interesting thing. Like the positions. Oh, maybe that was the issue too. Never thought of that. But yeah, anyway, so there's the normals of these like two vertices. Then we need to like let vertex index 1 equal the shape something something, what is it named? Test something something. That guy's vertices. Oh, we want the index. So like we're doing 2 of them. These are triangle strips. So like the index 1 would just be that times 2, or instead we could do bit shifted by 1. So little old C trick, multiplying by 2 is the same as bit shifting left by 1. And then we could say vertex index 2 equals vertex index 1 plus 1. Then the actual vertices. We gotta be careful in Swift because these are like how you say they're structs. So like for example, if we were to edit them, well, I won't show you the bad example of it, but we have to just access them directly. So if we say that dot r equals let's just say like %h is a float of that divided by a float of the big boy, the bad boy, that guy. So we just set all the R to like how far they are around the globe. Oh. So this vertices is not accessible. We just gotta make this a straight up var so we can access it. Is that gonna fix it? Is it gonna go away? Did we switch our colors back to the right colors? Be super careful. So man, this thing is like having a huge slowdown right now. Wonder if I need to like close Chrome and close Chrome and close terminal. Chrome slows the computer down more than anything I've noticed. That doesn't seem quite right. Maybe that is right. So they're slowly turning more blue or more red as they go around. I think that is right. So that's showing us like the actual percent. So I think it's like as simple as like the z value. So like if we just say .r equals z, or like normal z1. So let's make, so this is not gonna account for the rotation, and that's before where I got stuck was on the rotation. But like if the Earth wasn't spinning, these would be how much we would want to stereoscope the pixels, the base z value. Yeah, so what we want to see is it always being white, like where it is facing you the hardest. And I think it's going to be easier to see if it's squared. So there it is squared. And let me make the globe spin way faster, because otherwise that's going just a little bit too slow. This is more like that's like the real demo speed, but we want like a test speed, so maybe like 20x. Speed up. And we should be getting little printouts of that rotation. So it goes all from 0 to 360 in degrees. Yeah. So what we need it to do to stereoscope it is to always have a white tip. So like based on whatever that rotation is, showing that. Let's think about it logically. So what we want to do is take that point and rotate it by the rotation, either forwards or backwards. I think backwards by the rotation. So we don't need the y value. We just need the x and z. It's a bit weird. So this is like a 2D, 3D problem. Yeah, I think I kind of have a grip of it though. But yeah, I predicted that this was gonna take a long time. I just feel like we're gonna be guessing it. Man, look at this slowdown. This is crazy. Like even XCode is just stuck, man. It's just like dumb stuck. Jeez. All right. So yeah, let's let's do this thing. It's on the data strip itself, and we can use the normal values. So interestingly, like, I just made that percent. I don't think we need the percent. All right, so I'm 100% confident that I don't need Y. Y is like vertical up and down. Y does not influence the stereoscopability of this at all. So what we want is like base rotation 1 is, I'm guessing, but I've done these things a lot of times, -8 tan 2f of negative normal x1, negative normal z1. Let's just do 1 first, and then let rotation 1 equals base rotation 1. It's either plus or minus radians. I mean, so these numbers could be wrong. I'm good at this kind of math because I've guessed at it a lot of times and just had a lot of trial and error. But I'm not like the sauce expert here. Then I want to deconvert that vector, or that rotation, to a vector. Yeah, so let adjusted x1 equals sin f of rotation 1, and let adjusted z1 equals negative cos f of rotation 1. And that's probably the wrong guess. So I'm just gonna make them all be that, like, instead of worrying about both individually. So that's clearly wrong. So maybe it's minus radians. So that's it. That's already it. So this is ending up much faster than I originally thought. Then we just need the number 2, 1, 2. And interestingly, we don't need x, we just need z. So just the minus cosine. So then base rotation 2 is that of 2, 2. And then rotation 2, and then adjusted z2, 2, 2. And this should look very similar, but once we put on the glasses, it'll make a difference. Yeah. So that's it. These are the values we need. So it actually might not be negative. Maybe it's fabs of that. Now I want to make them into like the real things we want. So we want like stereo shift 1 and stereo shift 2. We want more like a magnitude than a vector. I think this fabs f, fabs if. It might just be abs. This is more like C, and C for floats you would do fabs if. But it looks like that exists. Oh, and then these don't exist. So let's not square them anymore. Let's just go back to the way we were. So something became wrong. Oh, dude, I didn't put cosine. So, like, I got rid of the cosine there. So this isn't quite right. We do need the y factor. So we should be like, because we don't want the pole fully shifted. So it's like this middle point is the most shifted. So we need the y to, and we can just probably multiply by the y. So let's do that. So we'll do the fabs of that times normal y, and same with this guy getting involved. The bad boy got him involved. So like that's the opposite. So I can tell you right now that like that's the opposite. So I think it's times 1.0 minus the absolute of that, and like 1.0 minus the fabs of that might be, I'm missing a parenthesis. Uh-oh, it froze. Got it. I think that's it. It looks a little suspicious. Let's try putting the red, green, and blue all to the same value. I would expect it to look less like a that little like line sort of thing. No, there's something wrong here. Oh, let's just like print. So let's do not fabs if. Let's just do 1 minus. That ain't gonna make a difference though. That isn't like the. So I think the difference is like we need to factor in the y as like a spherical y. So I would guess something. Say let factor y1 equals so to spherize it, like we can use sine of like the sine of the absolute value of that times, is it pi or pi by 2? I think it's pi by 2. Let me just try this sine factor y1 and factor y2 like that, and then we'll multiply this by that factor. Factor y1, factor y2. So like clearly it could be 1 minus somewhere. So like here could be 1.0 minus. It still looks like a line though instead of like a sphere. No, I think this is right. This is close enough. So I mean that we can see it gets darker at the edge all around, and then it kind of spirals in. And we can see it shifting around as these vertices spin around, which is just natural. We could probably fix that very easily by just simply having more vertices. Like we could go all the way up to like a super dense mesh, like 128 by 128. Might fix that. We might overload it. But yeah, that's like, it's butter smooth now. You can't see that wibble wobble at all. Okay, perfect. So that's like how much we want to stereoscope each thing. So I'm gonna check this one off, and this went faster. I mean, if we start with the time, well, we started at 12:10. So that let's grade ourselves. So I would say that my grade here is A plus, because I've done very good for that time. I'm gonna reward myself with a bathroom break because I gotta go, and then I gotta refill coffee. Get my coffee situation going. Okay, I came back. So there's a. I predict 1 to 3 hours for this next part to. Oh, because I say for at least one pipeline state. So let's do that. It's funny because I started doing it already. Man, the lag is brutal. It might be because I'm recording the video that it lags too. I don't know if there's like, maybe just closing Android Studio for now. I'm gonna close Android Studio. Well, it's like seriously still struggling. Wow. I think it's time to kill Xcode. Oh, there it goes. It quit struggling. I'm still gonna kill Xcode and reopen it. And I'm gonna kill the simulator. Maybe these can be reduced to like 64 by 64. Anyway, so the stereoscopic states. This is gonna be a little bit annoying, because I built some stereoscopic states that don't work, or like test ones. And I've done this before, so I'm honestly not just figuring this out for the first time now. But I didn't do it like the multi-state pipeline way. I did it by rendering twice and then mixing the images together. It's a little bit taxing on the program. So I have these sprite stereoscopic states. Maybe these can be used. I don't want to make the shape ones because I feel like that's just gonna bog down the. Well, let me think about it. So with for the bloom effect, we kind of need it. Or we can assume that part is not going to be stereoscoped and that everything gets stereoscoped. Like, there's just a universal stereoscopic shift. Yeah, I prefer not to add it to the shape stuff. So let me look at what I built here with the ones that exist. Sprite node stereoscopic left 3D fragment. So I'm a little bit unsure. It looks like I've already done a lot of this, so shifting that position 0 by verts vid dot shift 0 did. And then there's probably a vertex already for the stereoscoped one. Yeah, sprite 3D, vertex, stereoscopic. Okay, then I have shift red and shift blue. And I think I'm already was using these. So there it is, stereoscopic, triangle, blah, blah. And I'm already populating it to then so really like we just want to set these stereoscoped values here. Well, let's just get it rendering once first, but I mean let's try it all at once. I think I have a clue of what's going on here. So we can do dot shift red equals stereo shift 1. It would be shift red and shift blue. But like these numbers are gonna be too small. I'm gonna do times 100 for now. And I'm just gonna copy paste that and put vertex 2. I just want to see if that crashes or if there's like something not set up yet. I do frequent compiles. Sometimes that's good, sometimes that's not good. So it doesn't crash. I don't think we need this print. Then in draw 3D. So this, here's where a lot of it's missing. So let's do this step, draw 3D. And we already had the stereo buffer. But we're not using the right pipeline state, so I'm just gonna put a breakpoint there. It's pretty hard to tell what's going on. But I think it's working. I think that 100 number I picked is... So it looks distorted. So we want it to be distorted for stereoscopic. And then we can already see that it's... we happen to pick one half of the stereoscoped. Let me see which half it was. But yeah, so anyway, then in back in here in the data strip. So if these are like 500, like the pixels should be so warped that like they're like way off the screen or something, or like super warped. That's a little bit weird. But that's a very large amount to stereoscope the pixels by. It seems like there's something wrong with the depth buffer or something too. Let's see if we have the depth buffer enabled. In here it's like graphics or what is this? Do we have a reference to graphics? Or maybe just like an Earth scene before we draw the Earth. Oh, we are literally doing the depth state to that, less than. And I have these function hooks ready. Draw stereoscopic left and draw stereoscopic right. So I think it's just gonna be like replicating this function. Draw 3D for stereoscopic left. Let me just copy how it's named exactly like that. Stereoscopic left. Draw 3D stereoscopic left. I'm keeping all the light stuff because eventually we want to stereoscope it with the light shading and stuff. And then on Earth, well, let's make the other one too. Draw stereoscopic left, and then there's going to be draw stereoscopic right. Draw stereoscopic right. Let's try the other one. So there's stereoscopic left, and there's stereoscopic right. So one should be red and one should be green. So it looks like the red part is definitely red. Let's see. So yeah, the 500. We just want like some variable, so like let stereo amount is a float of like we want a different one for the iPad and iPhone. I don't know why I can't see. Oh, UI devices and UI kit. So we need UI kit. There we go. So if it's the pad, then like I'll just guess. Make it bigger than it should be 40. Otherwise, like 30. So we'll just multiply everything by stereo amount, stereo amount, stereo amount, stereo amount. So as we have draw 3D, we need the two stereoscoped ones. Draw 3D. Stereoscopic left. So I think we need two buffers. Maybe not. Yeah, that's kind of like fundamental. I should know that. But anyway, so then we can kill just about everything. And we just need the other one too, right? So there's left and here's right. And they're pretty much the same thing. You know, really it could just be one function. I don't think we need two functions. So it could just be stereoscopic. Unless we need left and right different, we'll figure it out soon. Because we're passing in the pipeline state. Whoops, I think I fanoozled that shkabiz. And it's gonna get not super tricky, but the number of steps to get to our real thing here is a bit hectic. So like when we click that stereoscopic, I've already got the hook set up. Like in Metal, it'll be in Metal Engine. So it's already rendering the things. Oops. And it's already not crashing. So I'm rendering one to storage texture. And we're clearing the depth texture. There is left. So is that function being used on Earth Scene? It's not. So like these are gonna be all same. Draw 3D stereoscopic left, and then draw 3D stereoscopic right. The Android one is gonna be harder. Oh yeah, and there's like a cool thing happening where I have the light spinning around on its own kind of pivot. I think I can do that to auto shift it. Yeah. All right, then these functions, stereoscopic left. So this is being called with stereoscopic left. This one should be called with stereoscopic right. Stereoscopic right. So let me build it. And for the regular render, not stereoscopic, let's go back to the night one, because that looks cooler. The night light. So in regular draw 3D, we'll render the night buffer. And you'll see these modern video cards are like, they're super powerful. Oh, yeah, it's like spinning at a crazy speed, but yeah, the night is working. But if I use this shader debugger, we should see those stereoscopic sprites somewhere. I don't see them. Oh, you know, I don't think stereoscopic was on. Let me make it on by default for now. So I want like a couple things. I want like the default value, like the default spread. Let stereoscopic base shift red equals like float 4.0, and then base shift green or blue to be the same thing. then on by default. So where is it? I think it's on here. Then we'll have to combine bloom and stereoscopic both at once, which shouldn't be too hard, but it'll muck up that engine code a bit. Then in the Swift UI, we just will set this to stereoscopic 3D. So it should be a black screen. I'm not sure what's going on, but I'm gonna take a picture of it. It looks cool. Boom. We're doing left and right. So these vertices are wrong somehow. I can see the two different textures though, the stereoscopic left and stereoscopic right. Let's use the shader debugger tool here. So then we should be able to see, I don't know how to open it back up. Is it one of these things? Yeah. So then if we just look at these buffers, there's our index buffer. It looks like we got the right. These seem like they could be right. Like with these zeros, obviously 13 is not the texture coordinate. It seems like we rendered the wrong thing. Wrong type of data. So it's easy to look at stuff like this in the iOS setup. But I'm a little bit overwhelmed right now. I'm gonna be honest. I'm like I'm reeling to keep all this crap in my brain. So it's stereo triangle buffer. And then when we draw, yeah, we're drawing with stereo triangle buffer. That isn't being used, it's just the earth itself. Sprite node stereoscopic left indexed, no blending. Oh, because in these functions we're not calling draw 3D stereoscopic. It should be 3D stereoscopic. So sloppy copy paste can set you back a lot. And I think we can just do that trick to tab it over. I don't know why something shows up. It doesn't seem like something should show up. It must be because we're rendering the blue onto the texture, but that's good news. We wanted to see something show up. I don't know how to like zoom in on this thing. There's the zoom in button. And I like just save this texture to the computer or something. Anyway, so what we gotta do is blend these things together. But the way I was doing it in here is a bit naive. Because I was smartly reusing this storage texture. So there's a pre-bloom texture. Let's not worry at all about the bloom for now. That's just gonna confuse the thing. Blah blah, draw 3D stereoscopic right, blah blah blah. That gets drawn onto this thing. Alright, so I like, we need to, since we're using the bloom, well, we have the pre-bloom as a separate texture. It's a little bizarre. Yeah, I'm gonna make two. Storage texture, stereoscopic left, storage texture, stereoscopic right. And you can be sloppy, like, with these engines. Like, there could be like 60 textures probably, and like the phones are gonna do fine. I base that on nothing, but it seems like it could be true. So there we go, left and right. So let's like make these textures the left and right. Your stereoscopic left, and then this one be stereoscopic right. And these the render target width, they're all the same size textures, but I have had a lot of big bugs with this render target width being the wrong value for one reason or another. All right, so that's our 3D. In this pipeline, there's 3D and 2D. So we can see this render path, blah, 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 2D. And that's happening no matter what. And no matter what, we draw tile. Oh, look at this. It does it differently. So there's draw tile and draw tile stereoscopic. So mixing old and new code is sometimes a dangerous affair. Let's get rid of all these comments. That's from an old version of the pipeline, of a different pipeline. So maybe we don't need two stereoscopic textures. I don't really like this structure. Let's see. Yeah, I'm gonna move this whole thing into the else block, except for just the present drawable and commit. So there's gonna be this version of the 2D pass which does just draw a tile. And we're doing anti-aliasing too, which is nice. Then there's going to be this whole other version of the 2D pass. So where's the tile? So there's the tile sprite. I want to make stereoscopic left sprite. And stereoscopic right sprite. And then I can just look for all the usages of tile sprite and plug in these two bad boys everywhere we're doing this. So yeah, so the same way we do load, we gotta load these. Load. So it's gonna get tricky with the bloom thing. But let's just do a basic thing first. So the first thing will be to do this with storage texture, stereoscopic left, and then let's make it say width left and height left. It sounds ridiculous that they could be different sizes, but it's good to just match the same texture with the same texture. I like to just see that work first. I'd like to see like a black screen and no crash. That might be a good first thing to see. All right, so we got a black screen. And we got these things being rendered to these textures. Are we calling that function? So we can just call that function draw tiles. It should be tiles stereoscopic. But it's gonna get hairier when we also are factoring in the bloom. I don't want to keep droning on that, but it's gonna come up. So let's just see if we get the one half of our thing to show up again. All right, so there's the one half. Then we want the other half. So I'm gonna copy everything that says left, and I'm gonna do the replace with right. So everything that says left can now say right. I don't see any lowercase. Yeah. Then we'll boom. And we can retab. Then if we run it, we should just see the red one. Yeah. So it should be as simple as changing the blending type to probably additive. I think it's additive. I'm almost positive it's additive. So it doesn't work. Let me put on the glasses. It's funny because the earth is blue anyway. Or let me take a screenshot of it not spinning. I mean, it should be more obvious if it works. But we can factor in the base stereoscopic thing. No, there's no stereoscoping. I think so in the shaders. How are we doing the right and left shift or the red and blue shift? Well, let's like so it's like essentially working. Like it's doing blending the two textures, but nothing is different in the two textures. They're the same texture. So that's my hypothesis, which I'm like 99% sure of. So it's got to be the red and blue values are not going to the same thing. So I think the shader should like handle the other shift differently. So let's go to the shader. Let's find stereo. So in left, we're going plus equals verts vids shift 0. And in right, we're doing plus equals vers vids. So maybe if this one was just minus equals that. All right, yeah. So you totally can see it being 3D. It's like too much, so the factor is too much. Let me put on the glasses. It should be like, oh yeah, it doesn't look right, but it looks like weird, wacky. Like there's definitely something going on with the red and blue. Cool. So there's like stereoscopic 3D basics. I'd like to go a little farther with this, where it just works, like where I can put on the glasses and I can toggle these things. Yeah, maybe we'll do it at the end. We're doing mixed development now, Android and iOS. The command came down. The iOS just isn't enough. There's just not jobs, or the jobs are taken. So that's cool, man. I mean, that's like wicked wow, dog. Like crazy 3D stuff. So I like to like leave this over there while I code so that it's like part of the video. Yeah, I'll go a little further with the iOS app and then shift to the Android Android app. So I'd like to add for other lighting types, but I want to get the base shift too. So like all those stars and everything should have a little bit of stereoscoping too. Everything should have like a little bit of shift. That's how the 3D pictures work. And I know that just because I've studied this a little bit in the past. And by studying it, like I did pretty close to what I'm doing now, only just slower. So I didn't actually study anything. I just kind of guessed at how it worked, and it's been kind of accurate. So yeah, the base shift, that should be much easier. So in Metal Engine, we can do the model view matrix equals matrix float for matrix identity float 4x4, and then translate the matrix. I'm just gonna make it by 100 first and just see if it's like got a wacky translation. No. Oh, because like right here on this next line, I'm doing something else with the same matrix. All right, so that like wacky shifts it. It looks like this is the red one. So we can call this the red shift red, stereoscopic base shift red. And we'll do the same thing with the other one. So instead of just assigning it, then it'll be shift blue. So maybe red and blue is a better naming than left and right. It's a little, I guess it doesn't matter that much. But you would think left would be minus and right would be plus. So we get like a tearing at the edge. I think the tearing at the edge could be fixed by just clearing. We're not clearing. But the question becomes, what about these stars? So we got the stars and the bloom ring, which obviously go away when right now we click stereoscopic. So it's a little tricky, and this code is getting very tall. So when we draw bloom, let's look at it. Let's look at what all the different phases are first. So first there is pre-bloom. Pre-bloom and bloom. Alright, I'm trying to overcomplicate it, but I don't think I need to. So, for pre-bloom, we always do pre-bloom. Whether we're doing, or maybe not. Do we? Let me look. So if I turn off bloom, no, I have the stars show up either way. The stars are pre-bloom. I'm a little confused by why. So here is storage texture pre-bloom. Okay, otherwise I see it just does the pre-bloom render like so. Ultimately rendering to where is the bloom call? Oh, here is the bloom call. So at the end of this and this, or just these two, alright, let's do it with no bloom first. Or just the generic case. So when stereoscopic is enabled, we're just ignoring anything with bloom. I'm just gonna always do this for now. So in the other case, I'm always gonna do the pre-bloom texture. So there's the pre-bloom texture drawn to storage texture pre-bloom. Then we have to draw that onto both halves, like each half needs to have that drawn. So we need a new shader for like a 2D sprite vertex, which is going to be so very similar could always just reuse 3D for 2D, but yeah, let's do it this way. So all this stuff, we need a clone. So every 3D should be 2D matching case, and every 3D should be 2D matching case. So there's those. They should just compile. Oh, look at it. So we don't have this thing, vertex stereoscopic 2D. So we just need that. So 2D, and this will just be a float 2. Is that it? No. And then in the pipeline, let's just search for stereo. So these all need a 2D. So we can replace 3D with 2D. And let's find where they're loaded. I'll do the same thing. Replace 3D with 2D, but need to be careful of the case. Lowercase, and then those can go here like that. I just want to see if it crashes now. Doesn't crash. And then we need the pipeline states. So those are the shader programs. So all the same junk here. We just need 2D. We need 3D to be 2D. You know, maybe this is the wrong approach. Yeah, I don't feel like having such similar 3D and 2D is that necessary here, because we really only need the 2D one to do this like stamp. We're not going to use this elsewhere, so let's undo all these changes. We don't want those changes. It's bogging down the pipeline for no reason. We just want that minus. Let's just make sure it still works. It does. All right, so we'll just use 3D sprites to do the rendering. Or like a 3D, yeah, 3D sprite template thing. So what we've done is rendered onto pre-bloom. We have to combine the pre-bloom and the bloom into like an aftermath texture for this one. We need another texture. So like we need storage texture. I guess it could just be called bloom. And then I'll just make a comment. We then combine the pre-bloom and bloom onto the storage texture bloom. Texture ... and we're gonna draw it on each half. Here and here onto the 3D one. So let's make extra sprites. So we're gonna have stereoscopic left, bloom sprite, and this is gonna be 3D stuff, so 3Ds. So we just need a Z as well. Stereoscopic left, bloom, and stereoscopic right, bloom, sprite. We'll just do these loads. Oh, these should just say sprite 3D vertex. Then we gotta do like the whole mishmash of all this kind of crazy stuff. Let's just do it on the left side first. Stereoscopic left sprite. We're gonna use the same texture for both. Storage texture bloom. And these width and height, so we can just make them width equal to that width and the height equal to that height. Which might be integers. Yeah, so we need float. It's a little messy. This should render the stars onto half. it doesn't do that. I think the reason we're not actually using that that texture. What we need is like an extra 3D pass. So we'll do an extra 3D pass. And instead of calling it 3D left, let's name it like Bloom Combine. So everything that says 3D left will be Bloom Combine. And if it says Encoder 3D, it'll be Encoder Bloom Combine. Isn't there some other name too? Alright, so we'll get that situation fired up. Where is it? Alright, then for now, we'll use just the pre-bloom texture. And I think this can be a don't care. But we write it to this storage texture bloom. To the storage texture bloom from, don't we have a combined sprite already? We need a combine bloom combined sprite, which can be a 3D one. So this gets hairy. We'll just call this bloom combined sprite. We can leave the 3D in there. And we gotta load it and all that stuff. And for all this, we're going to use this new bloom combine sprite. And there just isn't this, we don't need that delegate call. That might be it. I don't really know. So I don't see stars. Let's just look at what happens here. We get there. We have a texture. It looks like it goes through. And we're writing it to storage texture bloom. Let's capture the thing. Well, let's look here. Are we using storage texture bloom? We're we're using storage texture bloom on stereoscopic left sprite. I think that is what we want. So somewhere there should be 2 galaxy sprites. So this is pre-bloom. I can't tell if the stars are there or not. So the star image is like a little bit too hard to see. So let's just use the earth texture for the stars for now. And I'll just comment this out. So this is the pre-bloom pass. Oh, is it like... I don't know why the bloom, these bloom things are rendering. So something's wrong. Those shouldn't be rendering. We copied an extra thing somewhere. I think this draw bloom we didn't want to do. So there's one, there's the pre-bloom. So this is the very second render. The very second render. This is the very first render. The very second render is right here. Oh, look at this. We're doing storage texture bloom and not pre-bloom. So we want to do pre-bloom. All right, we got one step farther because now we have this rendered onto the other texture. Onto storage texture bloom. Let's just return here. So it just seems like that just somehow doesn't strike, doesn't. Oh, you know, we gotta like finalize the render, otherwise it doesn't work. To do remove. Oh, we gotta also end encoding too. I think like it's trying to return that call. It's real goofy. This is one thing I hate about Swift. Like return semicolon is different than a return line. Alright. So this should simplify our pipe here. So this is just on this call here. We have this binded to the fragment texture. Let's look at the geometry. Okay, so the geometry is wrong. We're not drawing like a real sprite. We're drawing like a weird top left thing. So that in the darn OpenGL, that would be so much harder to figure out. It could just be the width and height that are wrong here. Like we want to use storage texture bloom width and height. So we're using stereoscopic left sprite. Let's look at the stuff on the card. See, it'd take a lot longer to do on the Android because it's harder to debug. We got a buffer of 0, 1, 2, 3. Oh yeah, somewhere in this buffer it has the width and height. So it seems like we're using the wrong type there. Stereoscopic left sprite. Okay, so this says sprite 2D vertex, and what we want is 3D vertex. See, much harder to diagnose on without the shader debugger. Still not working. Okay, it actually is working. So it's there. But we need to do so it's working, but we gotta finagle it a little bit. So this is actually stereoscopic, 3D stereoscopic. Okay, that's because this one has to be named like that too. Shift red. And we might as well make the right one the same type too. I just put some number other than 0, so something happens. But we can use these base shift amounts. Yeah, why don't we just use the base shift amounts right now? I don't know if it's gonna allow that or not. Not worry about that yet. So then when we draw the sprite, we actually render it with the stereoscopic. So when we look at the metal, yeah, so we get that whole thing in blue now, or in, yeah, the non-red channel. The other thing is we do want to, if we are doing bloom, we want to do the draw bloom. So it's if is bloom enabled, draw bloom. It's funny, we can't like, I guess we could have both of these going at once. That seems a little unnatural. So at the end of draw bloom, it's gonna be that on something called bloom texture 2, we have the bloom effect. So then here we'll say if bloom enabled, and let's just find the other one and see if we can copy pasta it. Oh, see, interestingly, we were able to reuse that same texture. Oh, no, it's not the same one. It's pre-bloom and then bloom. So what we want is the bloom stamp sprite. We might be able to get away with like 1 or 2 less textures here. But yeah. So then if bloom is enabled, we can use the same render encoder. And the lucky thing is we're not on the left or right, we're on a universal channel here. So there's a little bit of extra crap going on. So if we look at it now, we should see that thing stamped on there. Yeah. So pretty cool. There's like the mamma jamma, and we're shifted and stuff. I think the load action here just has to be clear to prevent that one thing. But anyway, yeah, so then we can get rid of the remove. And we should just be able to fazoots all this shglagugity together. So as we've done the fazoo down here, we got the, not that, is that it? That's it. I've got a phone call, but I shouldn't take it. Just see who it is. Hello? Who's this? No, no, thank you. No, thanks, man. Sorry. So we can use the right sprite here. Right. And then this pipeline state is right. Now I'm confused why nothing is showing up now. Let's look at what's going on. So we got the left and the right now with the earth and the background earth and all the stuff. And the thing we're using so it does draw tiles stereoscopic. Oh, maybe it's the clear action that we don't want. We want like instead don't care. I don't know. We get all the way to that point though. The left and right channel. And then we use the one called storage textured there. And then the one's called storage texture stereoscopic left. So somewhere that should be used, storage texture stereoscopic left. I think this part is wrong. This should say storage texture bloom. But that isn't the problem. We're using storage texture stereoscopic left, and we're using storage texture stereoscopic right. I think it's because we're using these sprites twice. Yeah. So we can't use those twice. So let's just make an A and a B. So there will be A, and there will be B. And I'm just going to make these all that same 4.0. Then let's just do A's and B's. AB. AB. And here, I guess we're referring to A. And here we're referring to A. And then here, we're talking about B. Same with here, B. Dang. let's look at, there should be just 2 render calls. So we have right there, so we can see it. It looks like it's drawing a little tiny thing in the top left. Yeah. So there's a little tiny sprite getting drawn up there. It must be the geometry. Oh look, yeah, the texture coordinates are lined up wrong to this, so the pipeline state isn't correct. Oh, you know what? So like one of those A and B, the B is not stereoscopic. So those are just regular. And then we'll have a 3D going on. I think that might have been it. Man, of course that isn't it. But luckily, we're not on stinky Android, so we can see what's going on. We're still just drawing up there in the top left. Yeah, so the texture coordinates are coming up wrong. So it's easy to see the data is misaligned. Let's look at where this is being used. Right B. So these are actually 2D, not 3D. So these ones are 2D. The B's are 2D. So a lot of brain geysers happening. Ooh, and even this format is wrong. So these are not even stereoscopic. Oh, no, in A they are stereoscopic. Oh yeah. So in A they are 3D stereoscopic. In B they are 2D non-stereoscopic. So I think I got rid of the Z incorrectly here. And here we have the Z incorrectly. This is close. The background is not stereoscoped. But I can see the bloom halo. That's cool. Oh, whoa, what? We'll figure it all out. We'll get this done. We'll just knock this all out. You know, not with the lights. There's just not time for that now. Maybe tomorrow. Maybe later. Could be now. I mean, there's no real reason why it couldn't be now. But yeah, there's just one other little issue, which is we're missing a channel. We're either drawing the same channel twice or something. So we should be real careful. Like I think it's the right one, the right A or yeah. So we're rendering it with the 3D, blah, blah, blah. Let's look. So nowhere are we having on this one. On the green one, the very first render is the Earth. On the red one, hold on, let's look again. So on the green one, yeah, the very first render is the Earth. On the red one, the very first render, we have the, hold on, is the very first one just the Earth, or, yeah, it's the Earth with that little spotlight on it. So on the red one, we have the wrong one bound. Or no, isn't it the whole thing? Let's look at this one. So here, yeah, it is the whole thing. So it's there, it's bound. The geometry is like the whole thing. Here, it must be the geometry. Whoops. Yeah, so the geometry is whacked up. I don't see why it's messed up though. So in this buffer, nothing issue. It must be the wrong type or something labeled here. Let's look at it. Right, A. Okay, so this is supposed to be stereoscopic. So we need those shifts there. So it can take, that's the time compression issue we're gonna have with Android, is taking too long to identify that. But it still didn't work. So for A, we're using stereoscopic, blah, blah. Did we go and ruin something after the fact? So it must be the geometry is wrong again somehow. The geometry is somehow wrong again. Alright. Why is the geometry wrong? So it's definitely this thing. Sprite blah 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 A. Just to make sure. So if we comment this sprite out, then that call should disappear. Yeah, so we can see that that call disappeared. Here we can see the call is there, yeah. So it is this right here, we can isolate it to say that's the spot. We're doing storage texture bloom, storage texture bloom. Oh, you know, we're using A. Oh, left A and right A. No, that's cool. Let's just try putting the other one there. Maybe like it has some issue with binding that texture twice or something. No, so here we see it worked. And if we put this one in the other spot, it probably will still not work. Yeah, so it doesn't work. There's just some subtle nuance in A versus B, left A and right A. Let's look at them side by side. There's left A, right A. Let me just copy and paste left A and rename it to right A. I didn't see any issue. Maybe we're not loading one of them. Left A, left B, right A, right B. So we got this call being made. Is the geometry is still wrong. It could be something else is overflowing. No, I mean these, so it looks like just the position numbers are all wrong. It got all zeros for all the position numbers. Maybe let's, oh, they're both using A now, aren't they? I don't know why they're both using A now. One should be B. So I'm a bit lost. Does that mean they both don't work? We can see the texture there. So these are 3D vertex stereoscopic, sprite 3D vertex stereoscopic, sprite 3D vertex stereoscopic. Okay, so it's not A and B, it's A and A, left and right A. Oh, so look like this line right here could be the wrong line. And we're talking about left here, so this is left, sprite A. And then the other one would be right. So this should be left, not right. Stereoscopic left, index no blending. So I think it comes down to putting all the exact right things in the exact right order. We can see the whole Earth not stereo shifted. I think we just have to manually shift it. Yeah. So we just have to, somewhere we do model view matrix, shift somewhere, dot translate, blah, blah. So B, we're shifting to the left. I mean, whether it's right or left, I'll easily be able to figure it out with the glasses once I got the glasses on. So that'll be whether it's right or left, shift, red, and then the other. Why did they? Oh, they're both A. This is left, this is right. Okay. This is right A, right A, and this is shift red. Is that correct? Is A associated with red? I'm still not seeing it, man. It might be that they're not knowing that those are dirty. Let's look if it's writing the buffer. So it didn't think the buffer was dirty. So we have to tell it the buffer's dirty. We'll just tell it, we'll tell it all the buffers are dirty. And then same for the other guy. No. Just no. but surely it's rendering. So if I comment 1 out, we would just see 1 channel. Is that correct? Yeah. So it's like, it's doing it. So here we're doing shift red. Oh, we're doing shift red in both. Let's look at the way we're doing the shift down here again. Where else are we doing the shift? Is it like way down here we do the shift? I'm like lost at this point. No, for 3D, we're like managing the shift on our own. Interestingly, it's gonna like dip into the picture a little bit with the way we're doing it right now. But yeah, I'll worry about that bridge once we burn it. So confusingly, I sometimes say left and sometimes say red or sometimes blue. Oops. So right is red, left is blue. Why is it showing up now though? We're not using right A, are we? That's weird. Like, don't we have this commented out? Oh yeah, no, that's... So that was super bizarre. I don't know why it did that. But yeah, A is red. So this one should be red. And the other one... Let me look at the glasses. So on the glasses, the red is on the left, the blue is on the right. So left should be negative blue, and right should be positive red. I want to make sure I have that correct on the shader too. And that the colors are correct on the shader. So left is red. So here we have right shifting negative. Right should be shifting positive. And we have right being red, oh yeah, it's actually all backwards. Where's the other one? Yeah, so left is red. And right is blue. Right is positive shift. Left is negative shift. All right. That's the whole shibdippy. That's like a 3D image. It doesn't work. I think it's because it's close. So that's actually pretty close. It's too much, and it's like the wrong base value. So those like 4s, we've got to factor in those 4s because we're shifting elsewhere. That's it though, man. That's like kind of the recipe for stereoscopic. So in this mother trucker, so the shift red, so A, like I think the number should be something like 16 and like 12. Those are probably more correct numbers. And then it's going to be +4. So really it should be even smaller, like 12 and 8. And we'll just do 4.0 everywhere. I think the 4, okay, yeah, that does it. That is wacky, man. Like I got the glasses on right now, and that is like an honest to goodness 3D floating Earth. It seems a little bit weird, a little bit wrong. Let me try swapping the channels again. So that base of 4 is too high. So that 4 should really be like 2. I'll try that before I swap the channels. And like, I don't even want these to be variables. I just want to punch in the numbers. So where are those numbers at? -2. And then 2. So red is negative. This could also be part of the issue. Red is negative. Oh yeah, we had negative in the wrong spots. Yeah, that's kind of, it's like a subtle effect. Let me try swapping the things real quick in the shader. If for some reason it's plus there and minus here. So they both work equally well. I'm gonna go back to what it was. No, you know, I think it's the opposite. Because the left eye is left. So I think all my numbers are opposite. And these numbers might just be too small. So let me try to make it like 18. Let's see if it pops out more. Yeah, that pops out like, it doesn't really look exactly like a sphere. Well, it kind of does. Yeah, it kind of looks like a sphere. Let me try with the other shift again. They both work, that both have like the same effect. It makes most sense for the left to shift right. Yeah, I'm gonna go back to this. So for the left to shift right and for the right to shift left for the I channel. So I think they're all reversed here. The 2.0 and minus 2.0. I'm gonna swap them all. Minus 2. That one becomes a minus. That one becomes a minus. So left is a minus. No. We want right to be a plus. Or no, right to be a minus and left to be a plus. So this is left, we want it to be a plus. This is right, we want it to be a minus. This is left, we want it to be a plus. It's right, we want it to be a minus. Yeah, this is correct. So that's a stereoscopic 3D globe. Cool, man. And then I can turn it off. So there's where we're still missing the buck a little bit. Just that this is in the wrong spot. So why is that? Which one am I thinking about now? I'm talking about non-stereoscopic mode. So the big else. So the pre-bloom stamp 3D, I think should be different size. Like, I think it would be approximately that divided by 4. Let's see if that's correct. No, that doesn't do anything. So, like, the question I have is this the one we're talking about? No, this is pre-bloom. That isn't the one we're talking about. I think we're talking about this exact line, right? No. So with that exact line, there it is. And we're talking about bloom texture 2. but we're sizing those to like the same size. You know, it's funny because this used to work fine. I want to pull up the repository to see what it was. So it's on like this line, Bloom Stamp Sprite 3D. So, I mean, I can just put what I had before there. I don't think that changed. I think it must be something else that changed. That's what I had before. I think it's the same. But yeah, I mean, I think that the fix would be just be like ×4 everywhere. Maybe it's ×2. But I'm a little uncomfortable leaving that there. So that fixes it. But what changed here? And I don't know why it would be ×2. Because Bloom Texture 2 is the width of the drawable divided by 4. Well, I won't get hung up on that. It looks like there's a fix for it. So normal, non-stereoscopic, stereoscopic, with bloom, without bloom, with bloom, without bloom. The other issue, this tear on the left. So I think to fix that tear, it could be as simple as having the load action be clear. Will that fix it? Yeah. So that's a big expense for the graphics card, but whatever. And then putting the right texture back to an Earth scene. Yeah. So we'll just go back to the galaxy. Oh, it's very subtle. Oh, I can see some red and green on some of them. It works though. It takes me a moment to acclimate to it, but there's like a total 3D effect there. Let me see. the difference on phone. Yeah, yeah, it has a 3D effect. That's good enough for iOS. So that that essentially is stereoscopic. So I'm gonna go here. I'm gonna grade myself. So I'm gonna give myself like a C plus for that effort. And then the Android, that's gonna be the whole rest of our shkabiznits. So iOS and Android, but very cool. In fact, I'm gonna take a little break. Not like a long break, but like a very brief break, like 2 or 3 minutes. But yeah, you can, if you're following along, which you're not, you could grab your 3D glasses. Maybe you are. Thank you. Yeah, grab your glasses and, put on your glasses. Look at that. Take a look at it. 3D, dude. 3D, dude. So next is gonna be Android. And my videos are, I mean, you already see I've kind of crossed the fourth wall in terms of time, or in terms of like continuity. So there's not like a continuous start to finish project here. And it's gonna be the same here because I've gone and done a little bit, but not too much. So like I've gone and done a bit of work, getting all the way to the point where the Earth shows up. But my like level of preparation with GL shading language is not gonna be here. We're gonna have to like surf the web and stuff. There's gonna be a lot more web surfing and stuff for the Android. But yeah, I would just like to commit this XCode project first. And I'm gonna make a very exuberant commit message. Git add all git commit stereo 3D works. Cool, man. And then push that. So 3D works. In Android, well, first of all, let's pick a task. Let me look at my management stuff. So setting up Gaussian blur bloom, linking up the pipeline. So I've kind of combined that all into one bullet. So let's just do exactly what our assignment says, setting up Gaussian blur bloom, linking up the pipeline. So kind of the way to do this is what we have here, like the one texture being rendered onto another texture, but we need another step. So like we need to render to a texture, then render with our blur shader to another texture, and then to our texture. But the way that I have this organized right now is not at all like I've just wrestled with online code until some stuff kind of worked. So I'm like reusing these zippo vertices and all this junk. But I built an object that isn't being used called render target, and I want to use render targets. So like the idea is we're going to render to one render target, and then we're going to render the render target's output buffer onto something else. Like but I want to just search the web for like, oh, you know what, maybe ChatGPT can do this. Let's see if ChatGPT can do it. I'll just say, I don't want all these shaders. I think we have a couple extras here. Yeah, just these two would be enough. Can you to convert these to GLSL. All right, I want to use their code to do the sampling, but use my shader as a launch point. Let's name it the same as the other shaders too. What are they named exactly? Gaussian underscore blur underscore vertex. Let's find these. And they're just always going to be Sprite 2D. Whoops. So I want to copy from these names, Gaussian underscore blur, blah, 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 vertex. So the rename is, not as simple as right-clicking and saying rename. Okay, then there's two. So there's like the horizontal and the vertical. We'll do one first. Horizontal. So there, like, we're doing that thing, frag color, blah, blah, blah. I think the first step is to get any old thing working, like these shaders linked up with what was there before, so that if we're changing it, we don't have a wrong idea about where the source of the issue is. So let's make, I'd like, if I double click that and could select the name, I guess I can just select the name without seeing it being selected, huh? Alright, so a new file, or new Kotlin class. Shader program blur horizontal. And this is gonna be the same thing as Sprite 2D. Blur horizontal. I should look in the other project. Yeah, I'm doing like, so I'm not doing, oh, I am doing like the modulate color, yeah. And in fact, in the Earth one, we are using that. We're not rendering it pure white, we're rendering it a color. Fine. Okay, so here's this shader program, blur horizontal. Library. No, pipeline. So we can do the copy replace trick here. So there's sprite 2D, and then these sprite 2D are gonna be blur horizontal. So we can replace sprite 2D with blur horizontal. Yeah, that's fine. We'll just get the names from somewhere else. What? Oh, yeah. So the declarations can go up here. And the vertex shader isn't horizontal. It's just the blur vertex. So we got that name and this name. One and two. And we can just use the blur vertex. Then I really think we can reuse Zippo. So we just want like a new thing called like Zuggo. And we'll just use like the same basic logic from Zippo in Zuggo. And just anything that says Zippo we can replace with Zuggo in this file. How can I tell where this applies to? Whatever, fine. So there's Zuggo. And then let's put it in the middle. So we're not really using the middle of the screen. This is gonna be kind of rough to tell, like, if it's working. Unless we do like a huge blur. But we should be able to tell a little bit. Like I can already see like some sharding or tearing on the edges. Like it's a little hard to tell. And a lot of this is going to be reorganizing as we kind of learn Kotlin. Whatever kind of weird Kotlin thing maybe we don't understand what's happening in the world around us. Well, no worries. Because we got our Zuggo, boom, getting involved. Don't we get this thing involved? So we go down to the end, and we say boom. You get involved. All right. That worked. I mean, there it is. So all we got to do is change Zuggo to use, instead of program sprite 2D, it's going to be program blur horizontal. So everywhere. And interestingly, like it probably doesn't need to be changed everywhere except for where we just link the program, because they all use the same slots and everything. All right, so that still works. So if I go and like edit this fragment shader. All right, well here's where like we can look at what ChatGPT told us. Like just copy that junk. So I think texture keyboard must be that. Texture or color map is texture. What is the sampler though? So there's a yeah. So this is gonna get harder because we also have a sampler. How do we bind to the color sampler in Kotlin? What needs to be passed in? Can you do it with just OpenGL calls? All right, I'm gonna grab my coffee. So on our Zuggo, we can do the sampler junk. It's funny because like in Metal, the texture is called a sampler too. So like in here, the sprite, oh no, so they're different. There's the texture and the sampler. But in Metal, I'm using a sampler everywhere. They all use the sampler. There's a built-in sampler, but I'm passing in the sampler. But yeah, so then unlike init here, this is all gonna be like glass 20 dot something probably. See that. Whoa. Let me look at where I'm doing GL gen somewhere else. I'm doing glass 20. Let me just set it to the engine. I don't see GLGen samplers in Kotlin, not on class 20 dot either. So let's use the texture on the texture object. Okay. Yeah, maybe we don't need the sampler for this situation. Let's try that. So we're only using color map, not a sampler 2. So it's funny because just that nuance can make a big difference about what we're talking about. Whoops, why did the copy didn't work? Alright, so the center is this coordinate. And everything called color map is just this texture. So let's see the black screen or failing screen. So it just won't show anything there. So there's some problem in this logic. Let's see if it shows up again. Alright, so let's get ChatGPT talking our language. This doesn't work if I uncomment the commented code. It renders nothing. Otherwise, it renders the texture just fine. So it says the texture width might not be available. Let's just try putting like 1024 for the width or something. Oh, but it's still commented out, yeah. Let's like drill down here. So like if we just make it solid red, that doesn't even work. So if we just put just this line, like just like 1.0, 1.0, 1.0, 1.0, would that be a white? And we don't get an error, do we? Oh, did I name this thing wrong or something? So there's somewhere. Oh yeah, it's probably just because this didn't compile. But that thing is named wrong. So let's look at the library, the pipeline. So this should be called blur horizontal. Oh dude, why is it Gaussian? Oh, I guess it is say Gaussian. Oh, there's like this vec3 sum. Maybe that's the issue. Hello?
Hello, this is Jean, your senior citizen benefits. How are you doing today?
Alright, so this works now. So even just that line, vec3 sum equals vec3, that line is invalid? Is that what I'm hearing? So that line is invalid. Maybe if that line goes before this line. Yeah, so just that line is invalid. What if it's vec4? Okay, what if the line is not there? Yeah, let's Google example of Gaussian blur shader, OpenGL fragment shader. Let's just see if ChatGPT knows the answer. So, putting this line anywhere makes the shader not work correctly. Float r equals 1.0. That line is not correct. OpenGL, GL color, not working. Is it .0f or something? Oh, I have it commented out. Frag color equals like 1.0 1111 with no type. Doesn't work, right? I'm sure that don't work. vec4. That would be my guess, because I can see vec4 right there. Maybe it's a low p vec4. Well, let's try the regular vec4 and just make sure it doesn't work. No, that does work. But if I add this other line, it won't work. So that line, it just can't handle. Let's ask ChatGPT. It seems like if I put any line at all in the main function other than GL frag color equal something, the shader will not compile. I tried things such as flow A equals 1.0 and it cannot compile with the line flow A equals 1.0 above the line GL flag color equal that. But if I only have the line, then it does compile. This is an abbreviated version of the code, dot, dot, dot. Are we using GLGen shader if see if we get a printout. No precision specified for float. I'm gonna put it says this. So I think I need like low P. It says this. Yeah, low P. So if I then just say low P float R equals 1, what's the light bulb say? Oh, I think the sum too is oh, like this whole thing is bonkers because I've like commented it out and stuff, yeah. Okay, so then if I put low P, nah. Okay, so I think it's the F now. Alright, there, now I can have a 2-line shader. Okay, now can you fix this all to work with low P? Alright, so it's just a matter of making some low P. Well, let's do it one line at a time, because it's really had some trouble. Alright, that one line worked. Let me see if this one line works. Well, we'd need a little more. We'd need low P here. And probably this line doesn't work. Let's see if they changed it to something. Oh, is center step. Step X doesn't exist. Alright. Let's see what it says now. Okay, so the sum I think is supposed to be vec3. I'd still wish logcat would auto clear. I've never wanted the old log. And I never don't want to see logcat. It said We're not even using sum, are we? We're just adding one number to it one time. Oh no, yeah, because here it says vec4, so that should say vec3. I thought I did that. Alright, there's that. So then all these can go back to what they were. Let me just try putting this back here. Well, let me make sure that runs. I really want to isolate what the problem is. Yeah, that runs. So these must be low P floats. Yeah, so there's the galaxy. And then obviously we don't need that so the easiest way to know if it's blurring might be to use a simpler sprite. Test sprite, test.png. But yeah, we haven't learned too much Kotlin so far with this foray. And the support, it's funny because the support for that sucks, and that's like native to the system. That's like what they use. But it's easy to complain. Alright, so we're just gonna make a test texture. Test texture. Let's get rid of these prints. Test texture equals the then let's make Zuggo use that, and same with Zippo. I don't think it blurs. We can shrink it down. So on Zuggo, let's just make all the 512s be 256s. Let's just get rid of like some of these. Like we probably don't need most of that. So we would expect it to like come up dark. Oh, I think we got rid of the closing brace. So it does come up dark. What happened to Zippo? I think we're for some reason just not rendering Zippo. Yeah, we're just not doing mzippo. We're doing it with like the wrong target. So these are not needed, I don't think. So it's like that was a test. I'll think it's the 1024. Ooh, so something out of that lines I just deleted was necessary. Oh yeah, we gotta switch back to the frame buffer. So these are new concepts for me. Like there's always been frame buffer, but I'm not usually using multiples. Yeah, so it makes sense that like right now the 1024 can be like a real number, like just like I'll just make it like 64. It's a small number, much smaller. All right, I can see blur now. Like I'm more convinced now that it's blurring that. So like obvious cat is obvious when he's getting involved. And yeah, the involvements are beginning in a big way. Yeah, dope. So there's like the horizontal blur. Then we just need to do a vertical one too. That's not gonna take as long. So like I'll just kappa plappa and become vertical. And I don't think we need this thing anymore, but it's good to keep this little bit of code in case we get stuck. Or we could put it in the compile shader thing. Yeah, this is good to have. So in shader program, like when we load program, we'll just do the same thing and see if it's like we can even just comment it out. So the good thing, like these shaders, like once they're good, they're good. Like we probably don't got to get too crazy with that one anymore. The only other thing though, we want to pass in the width and height. Let's just pass in the width and height to both. So that's going to be a whole big issue. Yeah. Not a huge issue. Look, we'll have to go to the base shader program. And we'll just call it like texture width. Texture width and texture height. So I'm gonna zip it up right now because it's working in case we blow it up. Let me make sure it compiles and then I'll commit to the repo. Alright, so we'll call this the moment of horizontal blur. And I'm just using command line. Moment of horiz blur. Cool. So we've got our little backup. Then let's add those in. Maybe it could just be texture size. I think size is enough instead of width and height. And we can just use like a 2D thing. That's probably enough. The uniform vec2 texture size. And this 64 can be texture size dot x. And we can link it up. And we should get hairy again for a while here because we're not gonna like, we should just see nothing for now. But we might get a printout that this is at a real slot. No, it looks like it loaded nothing. Did we not, we're not printing this error. Whoops. Oh, I think I needed low P, probably. Yeah, so it actually works, but there's no blur. We're not actually binding a texture size. But yeah, then like in graphics, it's gonna be similar to color. Yeah. Just like we have uniform modulate color, we can have modulate texture size. Or not modulate, uniform's texture size. Texture size set. Then we can just do width, float, height, float. And hopefully there's like a 2F. Yeah, there is. Now we'll just put width and height. I don't think we need a buffer version of the same thing. And it will be uniform location texture size. And then in Zago, we can do that. Whiz bits. Boom. Like such. And then like texture. That width. And let's just give it like 32. What's it mad about there? Don't we have like width F too? I think we just want to have on texture width F. I have just some feeling that would come up. So then like width F equals 0.0 F. And height F equals 0.0 F. And then like width F equals width dot to float. I learned this. It's got to be to float in Kotlin. And height F. And I didn't know Kotlin at all. Like I'm pretty impressed with how fast I can do this. It can't turn back the hands of time. So the real impressive thing is how life is impressively fast. So I'm impressed by that. And in fact, I'm impressed by you. Alright, so this is cool then. We're all cool, everybody's cool. There we go, we got width of and height of. Doesn't look like it had an effect. Can we breakpoint? It's funny because like we cannot use that. Oh, maybe it's got to be this bug compile to use that. Is that it? Yeah, okay, I'm learning more. So we have width and height. Oh, look at that. I'm linking it to the wrong location to modulate color. So there's no way that would possibly be able to work. I like this. So I like having the debug, the bug build and the no bug build. I wish XCode had that. Because you got to do like 5 clicks to switch between release and debug. Oh, cool. So there's the real blur. So just to like confirm, if like I put, instead of texture.width, I put like 6, it should be like super blurry. Like unrecognizably blurry. Yeah. Cool. So those numbers have a real effect. And I just put 32 because I just don't feel like 0 makes sense to divide by 0. Cool. So then, like, just as we have this guy, we get the same guy again. Boom. But it's texture size dot y. And all these numbers move to the y. Oh, and it can probably be named step y too. I hope it optimizes this stuff. I think it does. So step x can be replaced with steppy. Then we need the true class. Copy that. New Kotlin class. Shader program blur vertical. Vertical. And we can just copy all the crap again and rename it. There's not really much hurt in doing this like copy paste stuff. Like I would say there's no hurt in doing that. Alright, then we'll do the copy pasta. And I'm just plopping that in text file. And then when we load, we get this. So let's just go boom. So anything with horizontal is like gonna be vertical. And anything with little horizontal is going to be little vertical. So then we can plop these in up top. Like so. And I think these ones kind of make sense to have be like a little family like this. And we're doing like an extra load. There's horizontal, there's vertical, horizontal, vertical. So we should be able to compile again, and maybe the blur looks better again. Yeah, so we blurred that up real nice and blurry. horizontal blur. So in Zuggo, we can just replace all the horizontal with vertical. We don't need to like test them both at once, so I just want to see this work once, and then we can move on to something meatier. I think that works. I think we got a vertical blur. Alright, I'm gonna take like a 3-minute break, just to stretch out a minute. Alright. So there's the moment of vertical blur. I'll make a repo commit here too, because I think we've twiddled a couple different things also. Moment of vblur. There it goes. So it's like, it's time to configure a real multi-step render, which I have like the rudiments of. Let's think about this for a minute. Like I think that We don't need a new class really. This graphics renderer is our multi-stage renderer. We're not really using the concept of a scene. So I'm a little bit, my head is a little bit frozen right now about like what the move is right here. So like this thing shouldn't be doing most of this kind of stuff. So I think what we want is a scene. I built this thing called Earth Scene. And here's where like learning Kotlin can be a joy. So I want to make like a interface graphics scene. And really, it needs like a lot of this same junk. So like we could have renderer. You know, I don't think it needs the renderer, but it definitely needs a width and a height. I want to give it the context. So the context, the graphics activity. I don't think it needs the surface view. And then like a function to draw. So maybe we want to reuse this onSurface created function. We'll fire it up with this config and stuff. So we want it to do like a few things. So like we would want a function like load, and then fun load complete, and then fun like initialize. With that eagle config. Let's just try to link a little bit up here first before we get too far ahead of ourselves. So the Earth scene should be one of these graphic scenes. Can it automatically conform? Yeah. but it needs those funcs. Like, I wonder if we can tell the thing that, like, how can we make it so anything that conforms to this interface must implement the functions? Okay, so it already must. So I see those errors. Let's just print all this stuff. Earth scene, initialize. Load and load complete. Earth scene load complete. And then the scene could live perhaps on like surface view, or not live anywhere. So it's tough to see the variables. It needs context and activity. It's tough to get back to the file I was in. Funny because I think the context and activity are the same thing. But anyway, so I digress. On this guy, render target. Or no, not render target, I'm sorry. The renderer. We want a scene. Like, that's like the first object. Scene. And then like an on surface created. So scene needs these things too. When we initialize, and we should be like expected to have them when we're initialized. We'll have the pipeline and then the graphics. Then in initialize, expected graphics pipeline and graphics to be set by now. Then we can do those sets. We can set graphics.graphics or scene.graphics pipeline equals graphics pipeline. And scene.graphics equals graphics. Then we can do scene.initialize with that config. Scene.load. Scene.load complete. And sometimes we would want these to be threaded and stuff. So we need the other variables. But they can start out as null. Like we can't initialize with those. Is that cool? We override those. And we fire it up with our Earth scene. I don't know if this GL context version needs to happen there. It makes more sense to have it on init. But this render mode can't be on init. So we can build and everything now. Well, I'm feeling a little bit overwhelmed. I'll just clean up a few things real quick. So like, I guess the first thing we should do is load a texture on the scene. Let's just do that first. So we'll load a texture on the scene. And we're gonna start to move this junk off of the renderer. So we're gonna just do earth map exactly the same as here, but not as a late init. Like I don't want to use late init, I just want it to be null when it starts. Private var earth map, graphics texture optional. Doesn't need to be private. And then in load, we'll just do this What's wrong with this? Oh yeah, so we'll just start it as null. So I mean, this like this isn't gonna teach us much yet, or like give us too much to do yet. Yeah, so there we go. Then let's make like a draw function, and they should match our metal pipeline. So like these are the things we want. We'll just put them all there. I don't think like we need a. We might need like the width and height. I think for all of these we want the width and height. It sounds ridiculous, but they're gonna be different sizes. Like the bloom ones are gonna be different sizes. So there we go. And we'll just override those all here. And we'll just really use like one test one for now. Yeah, renderer. Then, you know, we want like an update function to with like how much time passed. How can we measure how many seconds passed in float in Kotlin between 2 points in code? Let's add like a update function too. So like in video games, which this is kind of like a Fox video game, we would do like the update thing too. So update, and then like delta time. And I never used to do it this way, but I do it this way now. And we just have to make sure we implement that on our other guy. And I really want to print those at first to make sure they're coming up with realistic values. Earth scene update. Delta time. And close it down. So these are longs. So we can make a private var or yeah, var long or private var previous frame timestamp equals long of or let's just make it long optional equals null. Then we can say like val. We'll make it current frame timestamp. Current frame timestamp equals this function. And we'll say var delta time equals 0.0f. And then if, let's say previous timestamp dot let previous timestamp. Oh, did I get rid of previous timestamp? Well, somewhere I've like deleted the code that I meant to not delete. So we can say like delta time equals the current timestamp minus the previous timestamp. Divided by 1,000. And then scene dot update with our delta time. And then previous frame timestamp becomes the current frame timestamp. So that's kind of like a cheeky little update loop. Just want to see if that works. Like if we get like, it should first say 0 and then like 0.01 or something like that. Yeah, those look like the right numbers. If the first one's 0. Whoa, it does a lot of crap here. Whoa, all these unknown message from the debugger. That's like alarming. Man, I don't even know if that's the right compile of the app. Let's rebuild it and quickly kill it as soon as we see something. All right. Yeah, so we get the, no, so see, that's a bit interesting. So these updates come in really non-linear intervals, at least right away. Like we get these really weird ones right up front. Cool. Alright, and then just like at the end of all the junk, we're just gonna say scene.draw 3D. And we can just pass in our width and height. And we should see nothing change right now. So I want like a sprite class sort of thing. Let me find in Swift what I want to recreate. Basically this indexed sprite instance. And then anytime we want to render a 2D thing, we'll do it after. We'll first get the stuff we need for sprite instance into our earth scene, but then right away we got to build this object because I didn't do that before, and I really wish that I had that object like all the time. I'm trying to think what I need right now. We really need the stuff from Zippo. So it's a bit of a Nambo goofball thing, but like these are the things we need for our sprite instance. Like Zippo almost is our sprite instance, so it's not like a big stretch, like a big change that we got going on here. Whoa, so so I think like all these can be like nil. The sprite instance is gonna need these. Oh, it's not nil though, it's null. In Kotlin, is that how you say it? And I think like I did a sentinel object. Yeah, so these have to be created with a sentinel object. Like injection right off the bat. Well, let's like just say like array of oh. So I think even that has to be just optional. What's it got a problem with now? I think it's val instead of var. Let's comment it out. It's a little confusing where the error is coming from. What maybe this almost is never the answer, but it could be clean and rebuild. So it looks like this file changed. I think we just need the data array as an argument. Let's grab it from the repo. Graphics array buffer. Yeah, I don't know how this changed. Yeah, so this really could follow like the load paradigm. Like, yeah, I think there's an idea there about doing like load and just having these all be like null and stuff. We might break other stuff in trying to do this change. So let's follow that paradigm. Let's just make load load with graphics and data. And that's pretty similar to how we do it in Metal. It's diagram and graphics. And then we can do this junk here. And then on the constructor, so we're gonna break everything right now. We don't even need a constructor. We just empty construct it. Alright, let's see what all is broken now. I'm a little confused. Like, I thought we were injecting stuff here. But anyway, we should just be able to make the buffer. And then load the buffer with graphics. Then what's the data? Like, I guess we have the data. I don't know how that disappeared. Like, it's almost like something weird happened with my computer. I don't know. Shape vertex array. And really, we want this to be optional too. And then we can say like so. Why is it called data instead of array? It should just be called array, I think. But we're getting very far behind ourselves right now. This one can also be optional. So do the same thing, array.let blah. We could even put like a little, well, we probably already have if it's not -1. Yeah, we have if it's not -1. So we're gonna have a lot of broken things right now. Yeah, it looks like one of like these like auto fix buttons or something must have broke this crap everywhere. But here's what I'm gonna do. I'm gonna delete most of these things. I'm gonna delete everything but Zippo. Because they're all kind of clones. So we just don't use any of that. So all this junk, go away. And all this junk. I can't tell what file this is. It says we're on system.java, but I know we're not on system.java. We're on graphics scene. So there should be bugs all over the place. So if we go to Zippo, yeah, like the thing where we initialized that is like bonked. I don't know what happened to it. It's fine. I mean, we kind of would have to do this anyway. But it just looks like a ghost did this for us. What is it called? Vertices or Zippo verts? I don't know what file I'm on now. So let's get rid of a lot of this stuff. Like most of, I'm gonna keep it because we really need a lot of this stuff. And then in the draw frame, we can kind of skip on a lot of this buffer swapping junk. So we're just gonna do zippo.draw. See if we can build it. So we can. We're no longer clearing. You know, I don't think I wanted to delete all those. Well, it doesn't matter. I still have the Earth data and it's still intact, so. But I deleted the one that renders the Earth. But the hard part is still here. But luckily it's in the repo. So this is Zippo. Can we prove that this is Zippo? So if we just move the height to divided by 2, it should vertically move to the middle here. Yeah. All right. So then let's get the scene rendering the thing. Maybe the name vertex buffer isn't good. It should just be vertex, maybe array buffer. I don't know. And we could just, oh, like it would be like colon blah, but we could just create it. So it's now safe just to create it. I think like we could do the same with texture. Like instead of this, like we just set everything to 0 and stuff. And there isn't constructors then, there's just fun load. This one's just a fun load too. And we just val bitmap equals that, and then do the other load with graphics and bitmap and file name. And this is just going to be another load. I don't think we need to say this dot width f and this dot height f. Really, we could do it here. We don't need to do the underscore graphics. Let's see what that broke. Yeah, I think this is a bit of a smarter way to organize it. Did it not break anything? It had to have broke everything. Okay. So like earth map, we'll just say val earth map equals a graphics texture. And then here we'll just say earth map dot load. And we gotta be missing the same thing in another space, yeah. So we'll just create them up front. Val. And we'll follow the same paradigm as we grow in our code evolution. Like to be render target and these other things. It's cool just to like load the object and have it be like not yet loaded or somehow invalid. Oops. All right, so everything's still cool. No worries here and there. So on Earth scene, we want to think about the relationship between graphics or graphics texture and like some kind of a potential sprite instance, because like we could have two sharing a texture, so it's important to think that through right now. But yeah, let's bone it out, bone this out. So we got this set up, going all regular like, and then boom, and then we got to load this guy. Dot load with our graphics and our array, our verts. We can probably quit printing the updates. I think we're just going to be spamming. And then we're doing draw 3D, I think. If not, we'll change it into that one. But yeah, it's got to be. So let's go into Zippo. We'll just copy all this crap and put it into the other one too. Earth scene. Boom. There's got to be a bunch of missing stuff. So let's like change this around to red and green. Negative SVN. And let's make it like times 3.0 divided by 4.0 F. Okay, and the buffer I slightly renamed to vertex array buffer. What's the texture? Oh, we have like it's the Earth map. Let's make pi be 3.14. Oh yeah, we need the index buffer. Do we not have that? We have it. Are we creating it? We're not creating it. So we'll need that index buffer. Oh yeah, and I think we need this little line too with the projection matrix, make the ortho. But we're not guaranteed to have that until load. So really index buffer. Okay, index buffer is optional. It should be optional. Var. 3.14F. So when we do this, we can make index buffer optional. And we can use our it. Whoa. It. Let's just space it back how it was. Whoops. Can we build yet? Alright, so there's our two things. So we got like a kind of the scene is doing a real thing. Now we just want to make our sprite object. So let's make like a new Kotlin class. Graphics, sprite, instance, and we very much want all the same crap that's on Earth scene. Like our sprite and our Earth scene are like very similar. Not exactly the same. So we're not overriding stuff here. I don't think we need the activity and context or even the pipeline, but we need the graphics. And we need the texture. Or texture. Graphics texture optional equals null. The thing is, it's different. The smart way that we do this in Swift isn't gonna work here. So like having a custom uniform type that we can swap around isn't gonna fly. So we might need a whole bunch of different flavors of this. But let's just start. Let's just build one little thing we can use. Cause buy a whole bunch of flavors, like there's gonna be like 2 flavors. If we can do like a let's ask ChatGPT to fix this one for us. What is the problem with this syntax for a computed variable in Kotlin? Okay. We don't want 2 sources of truth if we can avoid it. Let's just name it with F. So we need a sentinel vertex still. ask ChatGPT to fix our syntax for us. All right. What is the good and proper syntax for this guy in Kotlin? T needs to conform to two interfaces, which are the important thing is we're learning as we do this. So what I learned is the T goes here, right there. So I was very close. So there's just not like the comma syntax or something. Or let's just copy what they did there. Oh, I'm getting lost. Let me just plop it in there. Something's wrong with that. We just don't have the init. Is that cool or what? Can it handle this? Let's Google or ChatGPT this. What does this one mean? Reified. Reified keyword is used in conjunction with inline functions. Let's just do it in the init. I think it could be in the init. No. Let's just comment the rest out. What's the error in this syntax? now it says no, it doesn't like that. All right, well, I don't think like being super smart about this is the right answer here. So like this sprite instance, this will just be a sprite 2D instance. We'll just have a bunch of them. Yeah, let's poke at it a little more. Like, there's the issue. Cannot use T as a let's try this. Only parameters of inline functions can be reified. I am lost. It still has the reified issue. I just need to ensure that the objects in the array conform to those two protocols. But the thing is, we just always want 4 here. Alright, that one can compile. Can we not have 4 copies of the original of the one sentinel vertex? We can constrain the sentinel object to always be a struct. It does not need to support classes. Then we are just creating one. Is that cool? We can build. I mean, aren't we already constraining it there? We also want T to be float bufferable. Yeah. Anyway, there's not like so this is the struggle with Kotlin, is to like constrain this array so that everything in the array conforms to those interfaces or protocols. I call them protocols in Swift. So what doesn't it like here? Just the name of it or something? Is there something I can do where array always has exactly 4 elements? I need to keep T generic and always have an array of 4 of them, where the T types are always data class. Alright, fine. It's fine to initialize it with 4 sentinel vertices for now, but this is not like ideal. I don't think we need this like requires do we need out too? Like, I mean, that's a little bit harsh. Let's just make one then. Graphics sprite 2D instance, which is a graphics sprite instance. One type argument expected for class. Okay, so it would be one of these of type vertex sprite 2D. Alright, this could be an acceptable solution, I suppose. But we just need 4 vertices. And maybe like we can give them like more meaningful values in case of error. And then we'll have like the uniform types on there too. And we might like override the draw to have like more stuff in there. So we can just say val vertices like that. Well, really, we need the init too. Well, no, we don't. We need the load function. So we need like load. So just like texture has load. Well, let's like make the main function we want. So we want like fun set quad, set position quad. So x1 and y1. Let's, whoops, x1, y1. Two, jeez man, 2, 3, 4, 1, 2, 3, and 4. So then we can call this vertex array maybe. So then vertex array 0 dot x equals x1. Vertex array y equals y1. All the way up to 4. Then we also want set texture coordinate quad, and I'm just gonna do copy paste or replace anything x is u, anything y is v, and then vertial around is vertex array. Smoking gun. I don't see. Oh. Oh, I have twice the same twice. That's the main thing we wanted to be able to do, so we don't have to have these arrays all over the place. So we need a fun load with like a texture. And we just say this dot texture. Oh, we lost our reference. Okay, can we go back to this too, like having this little speed up here? What is the problem? Must be initialized. Oh, like the set. We would need like a private set on the. I'm a little confused. Alright, well, we don't care about that too much. That's like, that isn't like one of the main things. But on load, we also need the graphics. We'll kind of do it in that order, graphics first. We'll do this dot graphics equals graphics. Then do we need like the indices and index buffer? Index buffer. I don't think we need like an alternate. We can be null here. All right. Then we just want these matrices. It's just going to live right here, right on this guy. And really, don't we need like a color too? So where'd color come from? Like on init, nah, never mind. Then we just need like draw or render. I'm gonna call it render. We don't need a width and a height. But interestingly, we need as an argument a shader program. Shader program optional. So we can do shader program dot let shader program. And the graphics dot let graphics. And then even texture dot let texture. Maybe not that one. Yeah, we'll let the graphics handle the texture. And the blend set alpha isn't really part of it. So these are not like questionable. These are like absolutely does exist. And it's always triangle strips. There's no reason for any other thing. And the texture is our texture. So we got vertex array, but not vertex array buffer. We take one of these graphics array buffers. Don't we have that? I thought we made that exact thing. No, we initialized with a vertex array. Don't tell me this doesn't work. Oh, can we just say equals null? Oh, I also want T to be float bufferable. Cool. And we don't wanna, we wanna always just create this. So we just, whoops, just create that buffer. And then we'll have like a fun set. Set vertices. Or set vertex array. So it's just always for. And then graphics array buffer dot like write this dot vertex array. We need like the set dirty, I think, too. Let's look at what we did in XCode. So here it's a little bit different. It's each little thing dirty. But I think it works different here. We only need to, the uniforms we always have to write. We only need is vertex buffer dirty. So that part is a little simpler. Is vertex buffer dirty. So every time we do this, we just say is vertex buffer dirty equals true. Not this line though. And anytime we do this, we become dirty. Anytime we do this, we become dirty. And then here, we can do graphics array buffer dot load graphics and vertex array. And here is vertex buffer dirty becomes false. So in render, if we're dirty, then we have to write. Like so. Wonder if we could just build. So we just gotta pass in the right thing here. Let's make one of these graphic sprite instance on our scene. So we'll just make a val blah instance. Let's go one of those. And then in load, we can do blah instance dot load with our graphics. And you know, actually we want, oh no, we got the right type, graphics sprite instance 2D. We'll just load it with earth map too, graphics and earth map. And then we can say dot projection matrix dot ortho. Width and height. Why don't we make an ortho that takes integers too? That might be a little easier. Width int and height int. And it's gonna be two float. Whoa. So then in draw 3D, what is it called? Render. Can render with the graphics pipeline dot program sprite 2D. So that works. All those things worked. You know, then I want to try like dot set position quad. And we have like SVN. So like if it's like SVN times 200, SVN times 200 plus 100. You know, the quad is too confusing. Let's do just our frame, our rectangle. So we're slowly taming this beast. So set position frame, X, Y, width and height. And then we'll just use set position quad, like X, Y, X plus width, Y, X, Y plus height, X plus width, Y plus height. Let's use that one instead, it'll be a little easier. So blah instance dot set position frame SVN times 300 plus 200. Then like 500 minus SVN times 2 or times 200. And always 600.0 wide and 480.0 high. So that's working. It's like moving around and like repeating and stuff. Then let's not do that, and instead let's do these same things for blah instance model view matrix. But we'll translate to just divided by 4, but the height will be times 3.0 f divided by 4.0 f. And the other one will be height divided by 4.0 f. And let's just rotate the opposite way. So it's much smaller because we we chose for it to be that way. So let's make like the frame like if it's like -512 and -512 and then 1024 1024, then it should be more centered in our spot. Yeah. So while we're at it, we might as well make like a 3D one too. I don't know if we need it, but it's not going to take that long to make that as well. No, well, the one we need is for the blur. So we need a slightly different one for the blur. But I think it naturally follows to make a 2D one and then a 3D one. So it's like literally no extra effort. It's very fast extra effort to make the 3D as well. Just want to be careful where we add our extra variable, because we want to keep those U and V that we've already calculated. Do we not have vertex sprite 3D? We do have that. So I made these, I did this just to be tricky. So I made positionable 3D that like inherits from positionable 2D. I don't see what's wrong. I don't see what's wrong. Oh, it's a type mismatch, so this should be 2D. Oh, I thought I put 3D. No, I'm not seeing the issue. But vertex 2D was expected. Oh no, shoot. This whole thing is type T. How did that change happen? What in the hell? Yeah, the editor here is very much broke. That's very dangerous. But anyway, let's make one of those just to test it while we're in the mood for it. Earth scene. There it is. So you make like var David Blaine is one of these guys. And then we'll just do the same things with David Blaine. But we use the other shader program. We should be able to see it like boof with this program. But we'll put it in like a different spot. So we'll put it like up there at the top left. So we're doing the wrong program. So it should be 3D. No, where's David Blaine? Let's see if it's like stacked on top of the other one for some reason. Are we doing something else with blah instance that we're forgetting to do here? Oh, we're doing height times 2. This should be like height divided by divided by 4. So we're probably just drawing it off screen. Yeah, there's David Blaine. Mr. David Blaine. I see you there, David Blaine, doing your rotation. All right. It's only going to get harder here. Let's think for a second. So what we need to is like a we need one of these things that does our blur shaders that are slightly different. So we might as well build that now because we're in the mood to do that now. Or in the mode, not mood, but mode. And it's like 2 other whole big classes. Like I'm gonna put them at the bottom because we're gonna need to like, or at least we need to overwrite the render function. Ew, the context menu is showing up on my wrong screen. So this will be graphics, sprite, blur, man, blur, horizontal, instance. And it's the same thing, but we need to override the render function. And all the only other thing we need to do is graphics.uniforms. What is texture size? Texture size set. Shader program. And then like texture dot width to like 32. And the same with height. Texture dot height of 32. We could just always do that in every sprite instance, but we don't want to do that almost ever unless we're doing these blurs. So what we could do is have like an extra little hook, like a bind additional uniforms. I think maybe that's better. So we can just make a open fun bind additional uniforms. And we'll just do that then. We'll override that. I think that's a bit smarter. And really that function could take the shader program as an argument. We'd need that there too. So we just want that one little line. These can space out, a little auto space. All right, let's build one of these and see if this works. We'll call this Tom Rizzo. Then we'll link up Tom Rizzo. Boom, boom. Tom Rizzo. Let's make a test sprite too. We're not going to be able to see the earth blurred. It's going to be unnoticeable. But I predicted this was going to take long. And well, we got the blur up and running. So that's good. We got the blur up and running. Man, my head is leaving my body. So as we have test texture, we can put the same sort of like test texture in the other guy. Whose name is Earth Scene. Test texture, and then we load. The same thing. And really, we can get rid of this junk. So I think it's time to get rid of all these things. And we really just use those sprite instances to do our drawing. We were using that SVN. Yeah, how about we just put like 0.1? We don't need to always see him spin. Nah, let's go back to having him spin. There's some value there. And we just don't need these parts, like most of it. And zip overs, not used. Don't think we need that one. Then we're loading Tom Rizzo. So we'll do like the similar thing with Tom Rizzo. Whoops. And then Tom Rizzo is gonna occupy the slot at the bottom right. So everything times 3/4. But with Tom Rizzo, we want to use test texture, not the earth map. Oh, and we bind them to our shader program. It's hard to like to understand if that blur worked. It really kind of looks like it did. It's a small amount of blur, so we apply that blur several times. It's much faster to do it that way. And what am I clicking now? So in the Earth scene, like my question is, if I just switched back to Sprite 2D, does the blur, does it look different? It does. I mean, it clearly is different there. Fine. Then we need one more. Last one. Vertical blur. And then soon the computer is going to be doing this work. And we'll just kick back while the computer crunches away. So just like we got blur horizontal, I'm gonna do it in here, horizontal. I guess it's just in the one place, it's named differently, vertical. Okay, so maybe it can just be called blur, because we're passing the, yeah. So there's a smart point there. Instead of horizontal, Let's just blur anything. We don't need two of these things. So we'll just make one other one. Geraldo. Hand jab. Let's put this guy into our lineup. Geraldo. Kaboom. And then we'll do our same code, often duplicating code, but yeah, we'll just little trigger heavy on the copy pasta. And we just want program blur vertical, and this one is program blur horizontal. So really, we shouldn't need to test those. Like, this is a little bit overboard. You know, it's funny that you know, I'm almost getting a headache from this, but yeah, so that's cool. The next step is gonna be a lot harder, or at least for me it's a lot harder. So I'm gonna decompress for a minute or two and like realign my mental gears. Alright, well I have coffee brewing. This will be my last cup, I think. So the trick now is this like multi-pass render situation. So we want to render some bunch of stuff to like render target, and then render that somewhere else. All right. So graphics render target. Let's just make our render target first. And one that we want is going to be pre-blur. We do the pre-blur and then the blur, and then we combine the two. So in the renderer, yeah. I think we can get rid of Zippo. Let's do that first. So we can just completely nix Zippo. So all those references to Zippo. We want to really narrow it down to what we're trying to do. So I'm just gonna make val, I'm gonna call it render target pre-blur, render target pre-blur equals the graphics render target, or pre-bloom. So we sometimes use the word bloom, sometimes blur. I'm gonna use bloom. Pre-bloom and then bloom. This is honestly plenty for now of render targets. And interestingly, just this class here manages the render targets. So I'm a little bit overwhelmed right now. It'd almost be good to do it with well, let's go very slow. So we need frame buffer index. No, I just want to build it here first, just get it like somehow running on graphics renderer, and then I'll migrate it into the render target. No, let's just go there. Let's just put it in render target. I don't know, man. I'm like, we can't ever like look at what all the crap on this thing is, or at least I don't know how to. I Google that. Like, is there a shader debugger or graphics debugger on Android Studio? Yeah, something like this would be nice to see what's on there. Android GPU inspector. Yeah, I don't want to get too involved with that right now. Yeah, so let's get it working here then with one object, one frame buffer. I don't think we need the render buffer. I don't remember what that was for, but I tested it. So there it is, frame buffer, render buffer. And this was the old code I had. I'm just gonna put it there, frame buffer handle. It's like sometimes these have a like a Z buffer or depth buffer, and sometimes no. So this junk text is something we need to. So this is like, we shouldn't call it junk text. Let's just call it frame buffer texture index. Is that the terminology? It is called a frame buffer texture. So we're actually generating, and this I figured out the other day, but we're creating like a big blank wad of pixels there. And then we go here to that frame buffer texture index. Let's see if it runs, if we broke anything right now. So we did break something, and it's because we need to switch back to the other frame buffer, which is 0, I think. Yeah. So that's it. We just switch frame buffers like so, and 0 is kind of the default one. All right, I'm gonna get my coffee, which has been done. All right. So I'm not like super worried here, because like I can already see us switching between the buffers. When I first set it up, that was the longest yard. So let's see. So then I'd do something real lame. So it's like we have draw 3D. I think we can just do draw 3D like twice, can't we? Let's just add one other draw to it. And then interestingly, like, I just want a bunch of stuff on here, and this will be a good test too. Like, I'm just gonna have a version 2 of everything, like a backup. And then obviously we can delete some of this junk. These will all be 2, but we're using the same textures. So there's like a little mini test going on here too, but I'm almost certain that won't be the issue. So then we'll just take all these same things, but we'll just put them into Draw 2D, and these will all be version 2. So blah will be this. Now let's just shift it down by like 100 pixels. So we'll just shift everything down by 100 pixels in all cases. And we'll like reverse all the rotations for everything. And we'll make the scale like 0.75 instead of 0.5. Just to add a little variety there. But as you can see, like, kind of rendering more stuff once you kind of got your render started is like a lot easier. Like, it's getting started that is the hard part, like anything else. So let's jump into, where is it, the renderer, or renderer, and just here we'll do draw 3D and draw 2D, draw 2D, draw 3D. And then maybe something went wrong with it. If we comment out draw 2D, does it work? Something went fishy somewhere. It's hard to tell. Let's just comment out all these load 2s. Is there errors printing? Yeah, I'm a little bit lost as to what went different now. Oh, I think I just had the rebind commented out. Yeah. So we need to be on 0. Well, if we want to see anything. Okay, so there's the first set of them, and then we just gotta reload. And I don't think we're actually drawing the stuff. Okay, but yeah, we could see that now where we're rendering the stuff like that. So let's be a bit careful here. Okay, that was a bunch of crap I copied from ChatGPT. So like for the 2D, let's do this. We're gonna render to our frame buffer, and then for 3D, we're gonna jump back to 0. So we should only see one set of things drawing. Then we are responsible for the drawing the sprite that we drew to that texture of. So it's a frame buffer texture, but it is just a texture. So for texture, when we load, sometimes we can load with a texture index. We'll say like texture index width height, and we just will say this dot texture index equals texture index. So it's a little bit goofy. It might seem a little bit like redundant. We don't really have to use our texture object, but we kind of have linked some other parts of the app to this. Could make a different kind of class called a frame buffer texture, but this is kind of like the same animal. It's the same thing. So let's be real careful. So I'm just gonna say val frame buffer texture is a graphics texture. Then when we're loading, like pretty much right here, we can load that. Man, it'd be so much easier to read what that stuff is. And we're going at our regular width and height, width and height. No. Can we build or not? I want to go very slow because I don't want to get into like a mystery lock. Then how can we render that thing? So we need like all this Tom Rizzo sort of crap, like a sprite instance 2D. Then we're gonna migrate this onto its own object where we can have it go like a couple times. So we'll just call it frame buffer sprite instance. We want to use this like a real name, like not a temporary name. Frame buffer sprite instance. And then right here we can do dot load graphics and our frame buffer texture. And then really, can we draw it right now? We want our pipeline dot program sprite 2D. That should be enough to get it on there, I think, unless we're missing something. Well, ooh. So we're not doing an ortho matrix, so we need the projection matrix dot ortho width and height. And then I need this function on matrix reset, so I'm just gonna add that right now. And we just go back to those variables. Alright, let's use our copy paste magic again. Whoops. So anything with var, we want to instead be nothing. Anything with float like that, we want to be nothing. Anything with comma, we want to be nothing. Anything with colon equal, we want to be equal. Alright. Then we want to like set a frame too, maybe, or we can just stick with the 256 one, so it should render kind of like in the top left. Yeah, so that's it. That's like the main problem. And I had that solved at the beginning of the day, but now it's more solved. All right, let's get our brain going super hard. So like I think why is it blue? So first of all, what's up with the color of it? Yeah, let's make it a different color. So like, if we can just recolor that, that would be a huge step forward, like so. I want to be a little bit different color. And then like just to size it to a good size, just to for the sake of size. So like maybe we can do the set position frame like 200.0f, 200.0f, and then 800.0f and like 782.0f. It'll just be a good bigger size. The other thing we need is additive blending to get it working. We'll worry about that in a minute. So first, let's break this off into a separate object. Graphics renderer. Really, let's get the Earth. The Earth render. I don't know, man. Now I'm doubting myself again. I'm not sure why. But I just got overcome by a sick feeling. No, something's very wrong. All right, no worries, no worries. Let's get it together. So the render target, we want to migrate like we want to migrate like all this junk to there. Let's do it more carefully. What's the render buffer index? I think we need that too. And I think the reason we need this is to put a depth buffer on the other frame buffer. But maybe we can just reuse the same one. We'll worry about it as we need it, so we don't need it yet. So just take what we need. And all we're doing is plopping that right there. So we want a fun load. And we want a width and a height. And we want to have a width and a height. And when we load, yeah, we need that too, the graphics. And I think we even need the pipeline here. So I'm just gonna put it there, graphics pipeline. So when we load, we need these two graphics. The reason we need pipeline is because this needs to do its own little thing with the shaders. So we're building a framework more than individual monoliths or individual self-contained units. You see, a lot of these things are interdependent. Like all this kind of graphic stuff kind of depends on each other. Anyway, then we can say this dot graphics equals graphics, and this dot graphics pipeline equals graphics pipeline. And then it's like, it's basically just this same code. We can make sure graphics is a true graphics here, like graphics.let. And we're just generating that big texture. And we can say this dot width equals width, and this dot height equals height. So it's funny because in metal, these textures are so much smaller. Oh, and I think it's graphics question mark there. I think we always want level 0. That's like the mip map level. We're never ever gonna mip map these render targets. That doesn't make sense, but it could in another context. So then we got that, this is kind of like it. You know what I wonder is if I can do like two double up that render. This is like a weird thing to think of. Yeah, let's not think of that yet. Let's get one working. So this is gonna be pre-bloom. We already built it. So in the renderer, we want to bake this thing up. That's funny because like we could do this stuff before the scenes load, but we want to just load with our graphics and our graphics pipeline, and then our width and our height. So like that one's pretty easy. It's just that size and all that. Then we can just comment that out for now. Like I think I'm confident to just comment out all this kind of junk. And we don't need like too much hand holding here. Like we can just kind of do it like this. I mean, I don't think we need to wrap all this stuff. This isn't like meant to be extensible. This is kind of like a fixed configurable pipeline. I don't imagine that somebody's going to be adding a bunch of stuff to this in the future. Maybe. But then we need like a draw, like a render function. There's just essentially this. And maybe we'll have another one that's like test render or something like that. Or we could just call it stamp. I'm not sure what we'd call it. But yeah, then let's just make that like I guess we'll call it stamp or just draw. I like render. Render is a good name. Maybe we want to make sure our graphics pipeline that exists. So then just from this file, we just want to do, what is it, pre-bloom? Yeah. Pre-bloom.render. Then all this can go away. And I think we'd get this drawing like on top of other stuff now. So it should, we want it to be like, so yeah, we're doing this set position frame. We don't need to like be always doing that. And like even this stuff can just happen on load. So we want the position frame pretty much to be 0, 0 width height. Oops. I don't like the way that the cursor navigates there. I'm gonna be honest, that's like a little rough. So we are encapsulating quite a lot of functionality here. Alright, so that's like essentially doing its thing. Now I want 2 render targets, both showing up at once. And we'll just change these frames . So just like we have pre-bloom, we'll just do bloom. And then let's set the frames to like this one will be 0.0. Width divided by 2 in height. And then this one, regular bloom, will be with the x at width divided by 2. There's rendered target bloom. So instead of doing this, we want to, we want to bind to render target bloom, and then we want to jump back to our self to 0. And let's clear it with like red. I don't think we're even gonna see the clear. We'll do render target bloom, pre-bloom, and bloom. So we're rendering 2 textures and then we're mushing them together. All right, that's a significant step forward right there. That's essentially like the trick. I'm gonna make a backup and commit now. It's like, how much longer? Let's look at our management goals. ETA 5 to 6 hours. Yeah, I think we're gonna be getting beyond that time limit. Two render targets. Because that is like, I'm just gonna grade myself right now. 1000% fail. JK, success. JK, nothing at all. Okay, so grading is done. All right, so let's get like super zoned. Like, let's go zoning. What I think we want to get like the earth to render the bloom shape. Like, yeah, so like essentially the circle. So on Earth, well, interestingly, pre-bloom should be the galaxy, and then bloom should be the Earth shape. Let's code it up real. So in our scene, we want like a real one of these. We want the galaxy instance, and then we want I guess it can just be called galaxy. And then like this little step right here is like not too difficult. But it'll be important to see that galaxy, because then we'll have kind of the confirmation of knowing about that galaxy. And that's a good thing, that galaxy. That's like, that's a win. Oh, you know, I spelled it wrong. I really don't want to spell the real ones wrong. I called it instain. We want instains. Galaxy instance will load galaxy. Maybe it can be called galaxy map. Like, I think the word map makes sense there. Well, it's a little weird. But yeah, then in the like in draw 2D then, for example, maybe the whole thing is just galaxy.render with the sprite 2D program, and we just get that little galaxy showing up. On one half of the screen, right? It'll just be half of the screen. So that isn't quite right, but it looks like we're on the right track. Yeah, I think it's just about like setting the frame, which maybe we can do it automatically in load. No, I don't want to do that. That's a bad habit to get into. Too much convenience. I really want to set each vertex here carefully. So it's going to be 0, 0, then width 0, then height, or no, then 0, then 0, height, then width, height. Yeah, we gotta change all these types. Don't we have like a width F? No. 2 float, we'll just do 2 float everywhere. Alright, so that'll be the galaxy. Then let's do the pre-bloom, or that is pre-bloom. So we should call that pre-bloom. I mean, we're doing the real thing now. So this is like, we're building that real app of Earth. So instead of draw 2D, this should be 3D pre-bloom. That's exactly what it is. And in our renderer, that's the one we'll do, pre-bloom. So, I mean, It's just using the, it's 3D pre-bloom though, so it's a little bit weird. And then let's just do draw 3D bloom. So one of them will just be empty, and then we'll go fill it in with the earth. Yeah, there we go. So we got pre-bloom and then bloom. In the earth, our scene needs to have that earth. So I'm gonna move this way up here. It's funny because like the order, the linkage order isn't gonna matter. Let's try to do it in like a logical order though. So it should be like somewhere before load. And then we would just go something like scene dot earth equals, we don't need m earth. This is the old way of naming things. It'll just be earth. So scene dot earth equals earth. We gotta create the earth on the scene. Earth scene. So we'll say bar earth is earth optional. Then in pre-bloom, or actually let's, yeah, we're not doing like the load business. But yeah, anyway, so in bloom, and do earth dot let it dot, we don't have these functions, but the function would be like the same here, draw 3D pre-bloom. Earth dot draw 3D pre-bloom with width and height. Width and height, width and height, width and height. So let's add it to earth. So it's not an override, it's just a straight up regular, scregular. So we'll loop through these bad boys. So for strip in our strips, it's going to be the same function. We're just going to pass that through. Draw 3D bloom. Width and height. Then we got to add it to our strip. Draw 3D bloom. And I've already got it kind of linked up, so it's going to be the shape vertex dot, or yeah, so this is a little bit of a stuck point. I just want to see if we can compile. Oh, oops. Okay, we can start the earth as null. Doesn't scene have earth? What is this scene? All right, you know, I don't want to make this too confusing, so I'm just going to make this be an earth scene for now. I don't really want to get hung up on the structure of it while all this stuff is in flight. But yeah, that can be converted back to the generic, and then we can do some kind of a preload step. There's no issue there. But what we really need though is like we have this sprite instance. We need the same thing for shape. So instead of sprite, it's shape. And I just want to copy all this crap. And anything that says sprite will be shape. If it's big, and if it's small, we ignore it. So there's definitely no blur shape thing, so we don't need that. And this is pretty simple to solve. Shape just doesn't have U and V. Other than that, the 2D and 3D ones are like very much near identical. Do we not have these vertexes though? We do have vertex shape 2D. Can we build what's missing? Okay, so we actually don't need these things to be texturable 2D on shape. So there's no texture stuff, and then we don't need the texture quad. And we don't need any texture anything, so we can get rid of the texture. So this is where kind of like a builder pattern might make sense. Like it's the way we do this is a little confusing, I'll be honest. But at the same time, sometimes making it too generic like makes it harder to use, like for a newbie, new guy, new person, like they might be like, well, this is real clever, but I can't friggin' read any of it or use any of it because it's all done so gosh darn smart that it's not even usable. So each one of these the Earth data strips will get one of these val. I'll just call this the Bloom shape instance. And then we can do Bloom shape instance. So it's not seeing that. All right, we got to tell it what type. So this is just a shape, vertex shape 2D. No, this is a 3D. Oh wait, vertex shape 3D instance. Yeah, that's what we wanted. We already have it baked up. Then can we just do like load? Yeah, we can do load with our graphics on our shape vertex buffer. So what's it not like in there? I don't understand that error. Okay, we definitely don't load with shape buffer. Oh, you know what? This is like completely wrong. This is to draw one square. So we should test this real quick, but then we have to do something different, which is like a reusable one of these things, or like a refillable one. So this is gonna turn into a big job. So let's just comment this out. Just want to get to the point where we can compile. So I just want to make a test one of these. Var test shape 1 is that thing, and then test shape 2 will be a 3D instance. I don't like to not to code that and hard abandon it. That's a recipe for problems. So it's good to test the things once they're there, at least once, just to make sure that there's no zombies. But I'm not even sure that we need this. But let's just give it some kind of a frame. So test shape 1. We'll have the frame of like 100, 100, 100, and then like 300. And these are all have F, F. Test shape 2 will be like 300, and we'll make it at like 300 and be like 600 high. So then just for now, in pre-bloom, or in bloom, we'll just render these with our graphics pipeline, shape 2D, and then shape 3D. But yeah, I mean, these should be going pretty quick. I mean, it's so similar that I don't really see where too many errors could have been introduced. But at the same time, things can be deceiving. But no, I mean, there's pretty much these things here. I think it's like upside down. It seems like the render buffers are upside down. That is not going to be hard to fix, but it's still something to think about. Yeah, let's just fix that real quick. So for whatever reason, these are upside down. Eh. Yeah, I mean, we could just be like model view matrix that we really need like a scale of y. We want like 1.0, -1, like that. Let's make that real quick. Don't we have scale, right? Oh, maybe there isn't. Oh no, there is. Alright, so as we have scale, would have to look at the old matrix class, F matrix. There should be like a scale X. Why does it show the HPP but not the CPP? Okay, it's just in different places. Alright, so it's all 4 get scaled by that, fine. So we'll have scale X, scale Y, scale Z. And this only takes a second. Scale X, scale X, scale X, scale X. Y, 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 Y. Z, 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 Z. So something went wrong. Is there like a bunch of errors? So without that line, is it fine? So it must be like we would have to translate it to width divided by 2 and height divided by 2. And then 0. Maybe in that order. Maybe in the reverse order. Well, let's not worry about this part right now. There's going to be a harder task ahead. So we're going to need like with these earth strips. It's funny because like we have Let's think about it for a second. So we got the data strip, and the data strip has these like a shape buffer thing like this. So really what we need is like a list, a whole big list rather than just the one thing. When I say the one thing, I mean the 4 vertices. I'm having trouble focusing right now. Where is it? Shader program. No. It's shape instance. So really what we want is like shape buffer. It's like the same thing, but it's a little tiny bit different. Yeah, it's different enough to almost warrant a new class. So we'll just call this graphics shape buffer. And the only real difference here is like that we don't need all the different little types like that, I don't think. We could have them. Like the, oh geez, look at that. It's crazy when it adds like a curly brace for you. Graphics shape buffer, graphics shape buffer, and we could just call this graphics shape 3D buffer and graphics shape 2D buffer, and we don't initialize it like this. These are graphic shape buffer, graphic shape buffer. So instead of initializing like this, we just don't initialize it. There is none of this like quad junk. It just doesn't work that way. And we load it with a buffer. And that buffer comes from outside. So we wouldn't load the buffer then like that. And we're not gonna be like doing right or whatnot. So there's not gonna be the concept of a dirty buffer. Maybe there should be. But we can do that from the outside. Yeah. In the iOS version, there is a dirty buffer, but for this one, we have that write function on the buffer itself. So just when we load, we just simply say like this dot graphics array buffer equals graphics array buffer. Oh. So this can be like a optional graphics array buffer. Started out as null. So there's like kind of these subtle differences, but it's quite a lot different because like we don't have like all the quad related stuff. So on the data strip we'll have one of these. So it'll be, could be called bloom shaped buffer. And like we're getting nutty with the word buffer being all over the place. It'll be a buffer of vertex shaped 3D. And then we'll just load it with graphics and shape vertex buffer. And then in draw 3D bloom, we'll do shape buffer dot render from our graphics pipeline shape 3D. I was just going to say, and if something goes wrong, we're going to have a hell of a time understanding what went wrong. But like maybe it's the matrix, so like bloom shape buffer dot projection matrix dot ortho with that width and height. Could be that, but I don't see like a little tiny one. But oh yeah, maybe like it was way off the screen or something too. Like I don't know if this is even being called. We can switch to the debug. And just resume. So it looks like this is processing. The thing is, this isn't gonna tell us anything anyway, so we can kind of stop it. Like if we get into that breakpoint, which I think we will. Well, so maybe we can just kill Android Studios. It looks like it's gonna have a problem here. Maybe force quitting it. And then reading up on this situation. So Earth scene. We are doing draw 3D bloom on Earth scene. Or I'm sorry, on Earth itself. which is calling it on each one of these things. Draw 3D bloom. Yeah, it could be nice to have a breakpoint to see what's going wrong there. Except we don't want that one. It'll probably do the same thing again. Oh, no? So it's not calling that. Maybe? Is this getting called? So let's step in. So this is getting called. How do I step over F8? Whoop. So the buffer we're passing in. Oh, you know, I think there's an issue with the indices. Even though we don't see anything, yeah, because the indices so in the shape buffer, we just have this these indices, whereas really when we load it, we want to load it with either the indices or an index buffer. I think it's fine to load it with the indices as a int array. And then we don't have our own array of indices. So then we can just make a int array. Oh yeah, so we already have the index buffer here conveniently. So I've computed this before, and we don't need the buffer there now because we're gonna do it with the other thing. But yeah, so we can just pass that in. I don't know if that's gonna solve everything. Cause like we could have saw something, should have saw something. Yeah, we're just seeing nothing. So let's look at what's happening. Oh, we're not in debug mode now. Oh yeah, so right here we're saying count 4 So we don't want 4. We just want like a val index count. I guess a var index count equals 0. And then when we plug it in, we can just say index count equals indices.size. And then this 4 is our index count. Don't know if that's gonna fix it or not. But yeah, we can't keep this pace. I see it. So I see the earth now getting drawn in that corner. And part of my question is, why is it there? So I'm gonna be right back. Let me take a quick break. Okay, so on Earth scene, we've got this draw 3D bloom. And we're passing the width and height like so. And we should be doing a like update too with like the rotation of the Earth. We'll get that after. I don't know if that's part of our goal today, but it's not like a burning priority. It'd be good just to get that little bloom, and maybe I'll quit after that. I don't know, but yeah. Excuse me. The bloom, and then with the texture, we're very close, I think, but it's easy to make claims to that's a different story if they hold true. So, and like we're talking then about like different sized textures and stuff too. So I don't know what could go wrong. So on this, oh, we got the width and the height there already. So it's just kind of like the model view matrix dot reset, and then dot model view matrix dot translate to like width divided by 2 and height divided by 2. And then 0.0f. But I think I tried that before, and like for some reason that didn't put it in the right spot. Let's see if that's the right spot. Well, it makes sense. We're not using like a fancy camera matrix. Okay, yeah. The camera matrix isn't that much extra stuff to set up, but this is cool. So that's kind of what we want there. Then let's get the textured earth drawing too. That shouldn't be too much of a reach. So we'll just call it like the sprite, the I don't know, the skin sprite buffer, or just the surface. I don't know the word. Surface sprite brother, and then vertex sprite 3D. And then while we're getting all this junk fired up, we can say this guy load graphics, and we already have the sprite vertex buffer there, and the indices are going to be the same indices. So what could happen is we just do the same thing twice here, once with the other buffer. But we need the skin really, we want it in the init here. So var texture, like so. And then it gets a little worse. So that, like the graphics shape buffer, we really need a graphics sprite buffer, so we got to make that too. And we can't use this stuff here. So let's just get compiling again real quick first. Sometimes just getting compiling is some of the challenge. But yeah, so here we need the texture here too. Texture, graphics texture, and we just stick it in there like so. Let's see if we can compile. Yeah, we gotta, wherever we're creating the earth, stick it in there. Earth map. Alright, so like we have graphics shape buffer, we need graphics sprite buffer. And these are not as smart as the Swift ones, because those ones can grow and shrink and stuff. These are not going to do that. So I'm just going to replace shape with sprite. Interestingly, oh, no, I'm thinking wrong. Never mind. We don't need a whole buffer for the blurs. That's what I was thinking, is if we needed that for the blurs. Oh, that's funny, it doesn't know of int buffer. Why is that? So sometimes these errors are confusing, because here we have int buffer just fine. I don't know why it says that as the error. But yeah, we need to conform to the other type too. So T needs to be texturable 2D. No, it's just a weird error. Is he gone now? Is that the only line that it has trouble with? It looks like it. So if I add int buffer, okay, then it's like can import it. So it just needed to import that. And then similarly to drawing the other sprite thing, sprite instance, like we do uniforms texture set. So we need that too. Uniforms texture set. And when we load, we need a texture. And we can just have that floating around somewhere. And we'll just do this dot texture equals texture. Now we got that. So we can go back to our data strip. And we'll just have to get that there. Graphics, sprite, 3D buffer. That's what we want. And then it should just be a texture. And the program is program sprite 3D. Okay, so it's there. And it's the same problem I was talking about with the upside down. To be honest, I'm not super concerned about it. The thing I'm concerned with is a little goofy. I think it would be to get that blur effect. And then to kind of composite the things together. But yeah, I mean, zooming out, I mean, this is, I'm impressed. I mean, I think this is sweet. So we got the Earth there and the galaxy and all that shizwit. So we just gotta keep plugging away, plugging forward movement. And that's all we can do. So as an analogy to the other app, so this is a little bit tricky. So we have that bloom target. But what we really need is like the bloom target and then bloom target 2 or something like that. Yeah, let's make bloom 1 and bloom 2. But it's funny because this draw 3D bloom is just like one function. This is just like essentially all the job of this render target. So it's 100% going to be doing this stuff. Oh no, not render target, renderer, I'm sorry. So I'm gonna change things around. And I'm gonna say, so we have the render target pre-bloom, render target bloom. Yeah. Then we need like 2 more. I'm gonna call them that like blur 1. Blur 1 and blur 2. And these ones we can follow the same rules as before. There's blur 1, there's blur 2. In the other one I did divided by 4. So like they're much smaller than the real screen size. Because if we're blurring, well, I need to explain it in detail, but essentially we don't need like we don't need all the detail of the blur, because the blur is like a blur. Then I don't think we need any other objects. So we do draw 3D bloom. So like essentially right here, we juggle. So I'm gonna put juggle the blur. So we don't need the clear. We just bind to this. And then we take the darn we do like a we do need some other objects. We need two little like sprite instance objects. So we need like blur instance 1 is a graphics sprite instance, sprite 2D. No. So it's like we use, didn't we make the blur ones? Yeah, sprite blur instance, yeah. And then blur instance 2. And these we load up with graphics render target blur 1 dot frame buffer texture. Blur 2, blur 1, and blur 2, like so. And then we'll just pass it out. So it's a little confusing. The first time we come from a different target. So the target we come from is this target bloom. And I think we just render that. Then let's just go back and render this back. So like at the end of all this junk, we just render this one back. It's a little like weird. And I like expect to see something sized wrong. Ooh. This was intentional. I made all the pixels come up noise on purpose. So in render target blur 1, it's almost like this render target bloom dot render didn't do anything. So if instead of render target bloom dot render, we did something different, like like scene draw 3D bloom or something, would we have something show up? Could be like we're running out of stuff, like we're overflowing. Let's not do either of these actions. I just don't know if we're doing something twice and that's a problem. Could be. Oh, this should be juggle, not juggle. Juggle the blur. What I wonder is if there's some issue with it looks like these pixels are like bigger than a pixel. So if I start out with not having like this size issue, like I know it's on the render. So like if these are just not divided by 4, does that make any difference? Like are they like more able to see? Because we're like already drawing something off screen or something. I would expect to see at least more pixels, but I'm not sure. Okay, so it's like exactly that. So it's exactly that it's drawing in the wrong spot or drawing. Let's make it like divided by 2, divided by 2, divided by 2, divided by 2. Because like it could be just we need a different ortho now and a different let's just look at it again. So render target blur 1. I don't know if we do that. Will it be the right size? That didn't make a difference. But anyway, I digress. So if we don't do that call, we do that call, render target bloom, render. So these sizes are all over the place. Let's not have any size discrepancies. Everything's sized to standard size. And we can't debug the thing. Like we can't just look at what's on these different slices, but we can kind of imagine it. So we got render target bloom right there. I think, oh, it could be like because render target bloom is drawing way off to the right. So like our little test might be hurting us. Yeah. And then down here, we're doing this division. So render target bloom. Are we using render target blur? We are using render target blur. All right, let's not set that position frame anymore. So it's hard to tell what's going on. I don't know where we're drawing the half size thing, so we don't want this kind of stuff anywhere. Render target bloom. What I want to do is like take the, so we're not rendering like with the blur filter though. That's one of the things. So we're just using this built-in render function. And instead of that, we want to do, so luckily that's tiny. But yeah, we just want to do it with the blur function. Select render target bloom dot frame buffer sprite instance graphics pipeline blur vertical horizontal doesn't matter. Can't tell what happened. So if we hide this, all right, so that is happening. And it must be doing the blur shader. We're using blur vertical. It's just, you can't really see it because it's such a faint amount of blur. Let's look at the thing and see if it's really there. So if we just make this 1.0, we should have like more redness there. Yeah, so it's doing that blur. All right, so now we just bobble it back and forth once, and then doing it more than once should be trivial. So we go vertical, then we'll do the other one, blur 2, but this time we're gonna render from render target blur 1 frame buffer to like horizontal, like so. And then down at the bottom, we'll do blur 2. And we probably don't need to make it red like that. I don't think it worked because it should have been red. Why didn't it stay red? I don't understand. Let's get rid of this line and see if that line is having an effect. Should be. It should come up as noise now, right? Okay. So this line has an effect. But why did we lose that coloring? Oh, we went back to what it was. So. Then we just bobble back and forth like once or twice. Let's see if we can do it. And we won't worry about the sizes even today. It's getting to be a bit of a annoyance. So we just go right back to the other one. Blur 1. And then we render 2 onto it. And then we go back again. That's 4 of them. 4 blurs. We should be able to do like four like loops or several loops. And then at the end we're using render target blur 2, which we are doing there. Yeah. And it's almost like the color is like muddled or something. I'm not sure why the color is muddled. And I really don't see the blur. I expect it to be super faint. Yeah, I can't even tell. What if we just do a loop until 1? There must be some error somewhere here. I have just some weird feeling there's a bug. It could just be that we can't overwrite the stuff like that. In Metal, we can overwrite it. So why does it come up faint? That's another question. So let's look at this thing. Sprite instance. Do we have like a weird value for color? We don't. Couldn't just be like just because we have a blue background and the thing is blue. But let's go into the Earth model data strip. And we really don't do both of these. We just render the shape stuff. I don't see any blur. But we proved that it did blur. Could be the logic is a little different for some reason in here, so I don't know. Let's just make it like 111 or 100 or 101. Then we'll go back and forth again and see if we lost the thing. Really, let's do some weird thing like some .g. Yeah, I can see this little outline here. But it looks like it's getting fainter and fainter. Alright, so on renderer, if we just do this one call one more time, what happens? Did we like somehow lose our mojo? if we go back one more time, I mean, we're using render target 2 anyway at the end of it all. So I can't tell if it's like super faint. If we just do this call twice, we don't bounce back and forth. Is this somehow moving it? So for some reason it's getting real faint. So if we just only do the 1 pixel, times 1.0, this is just the blur itself that's wacky. I don't know if the range, like, what is the range of GL frag color? So 0 to 1, that's what I thought. But anyway, there it's a bit brighter. I don't know if we got a lot of advantage into going too deep into this here now, but yeah, so if we have this other render, it's not like just some weird thing like the color is the wrong color or something, or we're doing like an excessive amount of clears, or like is this gonna be like something we can see very faintly, or nothing? Yeah, so it's very faint. So if we do the same thing here, this 1 times 1.0, maybe like the times 3 and all this stuff isn't really the right number. Alright, so that's like, I like to guess at things. Like, I have this feeling that it might be like times 3 or times 4 or times 2 or something. I don't see why it would be times 3 though. Times 2 maybe? Let's ask ChatGPT. Let's make sure it's still connected. Yeah, see, ChatGPT like kicks you out. And it's probably not gonna reload right now. No. Why is this shader getting increasingly faint with multiple renders? It seems to me like the values sum up to 1 ... It says they sum up to 0.83. Let's sum them up and see what they sum up to. So 0.3 plus 0.175 plus 0.105 plus 0.07 plus 0.07 plus 0.105 plus 0.1775. Now they sum up to 1. No, that's like just plumb wrong. I don't know, but like I don't know. So like maybe we can try ×4 because it would be moving RGBA. That's the number that makes sense to me, 4. But it looks like we're going to the X and Y like what if it's like times 0.25? Is it like easier to see then? It couldn't just be like just one has a bug. Like if I just do just horizontal for everything. That might be the issue. So if horizontal just doesn't work at all, maybe only the vertical one works, so that was the issue. I don't know. So with vertical, this must be the one I changed. Yeah. So if I go back to what it was, so if we just do it one time, we rendered it to render target blur 1. So we just render target blur 1. This should be slightly blurred, right? But still 100% white. So it loses its whiteness there. And the reason is because of the shader. Yeah, we gotta get ChatGPT. Or maybe we can just find a bloom fragment shader OpenGL. Why is this shader, if I use the commented code, turning up so faint? It seems it is supposed to be a simple blur shader. Oh geez, ChatGPT is still not ready. What does this one do? So the UVX, what is the size X? Yeah, they're just doing that times size. They're not doing like a step thing, are they? No, they're doing like so bloom spread is what? Are they passing that in? No. They have bloom spread as 1. But they're using that textile fetch function. Oh man, I wish ChatGPT was awake. Bummer, man. I don't know. I rely on ChatGPT. But it isn't loading. It would have loaded up my conversation if it was loading. Text offset y is 1 divided by that, yeah. Maybe it's like the low P thing. I wonder if that's it. No. So like if they're all times 2, I would expect it to be twice as bright, or like some factor brighter. It just seems like these numbers are wrong. Yeah. If you multiply these or add these all together though, it comes up to 1.0. What if like the step y, like that should just be brighter again? I mean, it's like just using the same pixels multiple times. So even if it's like just the same one that many times, it doesn't add up, right? No, then it does add up. So, like 1 divided by texture size times 4. Or 4 divided by texture size. I think it needs like a sampler, maybe. It can't do like a weird sampling. What if they're all 0.1? So like this is really the opposite of learning Kotlin at this point. So my goal is kind of fuzzy, unlike this texture. Hey, what happened now? There must be a bug or a oh yeah, I didn't close the parenthesis. I mean, there you kind of see it working. So if it's just much smaller, so that's like 0.1, 0.2, 0.3. Are we doing this twice? We must be doing it twice. So it's got to all hinge on this step y. So if step y is 0.05, and we just go back to this old logic, step y times 3, and step y times 2, step y, and here's step y, step y times 2, step y times 3. I think I made it like bigger than I wanted. It's almost like once that number gets too small, it stops working or something. I don't know. Because I mean, exactly what it was before was 1.0 divided by texture size dot y. What if it's texture size dot x? Well, let's just comment it out. and put in some junk for now. So the number will be 0.005. And we can probably go back to low P. And like 0.001, like 1,000th. Yeah, fine. There's just some wrong thing with that math. I don't know what it is. But we can do the same thing with x. Just make the number 0.001. Was it 000 or 000? 001. And then back here, let's do for loops again. And I don't think we're binding to the right one at the end of this. We want 2. So that was a bit unfortunate. But there we go, blurring in one direction. So now I want to add the horizontals back in. Horizontal, horizontal, horizontal. Let's just do it one more time too. So we got 6 of them. And then onto the bloom target, we really want to do it on pure black. Oops. Is that the one? Yeah, render target bloom. I don't see horizontal blur. If we just did for I in 0 until 20. There we're doing X. Oh yeah, so in this one we're just not using the right output there, so that there is that problem. So yeah, it's just vertical. I still only see vertical. So if we did like 100 or 100, it's just gonna be vertical, right? If we're doing vertical and horizontal, we're starting with horizontal on blur 1, then we're rendering blur 1 to blur 2. Blah blah blah, back and forth. No, there is horizontal and vertical. Fine, but we just don't need a whole bunch of them. And I think we can increase the density of our Earth now too. So like instead of 8 and 8, these can be like 64 and 64. Then we need the other blend mode. So and we have it inside of the other project. Whoops. So somewhere there should be the phrase additive. Blend set additive. This is the blend function for additive. That's the one we need. Alright, so in the graphics library, we just need the same thing. Blend set additive. Source alpha MGL1. Alright, then an Earth scene. Or no, in the renderer. In the renderer. So we don't need the clear, but we render the pre-bloom, and then we're gonna do graphics dot blend set additive, and then render target bloom dot render. Let's just see if we get the blur showing up on top of the galaxy. We do, but it's not blurry though. So if we do 10 times the blur, I think it might just be a huge render target. No. The additive is not working correctly. So I don't understand. So if this is like 400, would like the whole thing be like crazy, like white all over the place? No, because we're not using blur to, so we just want to render to blur to, not pre-bloom. So we want pre-bloom and then blur to. Alright, so that's pretty much it. We shouldn't need 400 loops. And then we just draw 3D regular, which I don't think we've implemented yet. Let's just see, draw 3D. Earth scene regular, draw 3D. Maybe we do have it implemented. Yeah, so here is all this other crap that we don't use anymore. Let's get rid of it. So on the data strip, we just want a function called draw3D. Draw3D, there it is. Then we'll mix that shkabiznit. And in the renderer, we have dot draw 3D, and here, so we don't want this test shape 1 and test shape 2 anymore. We're over it. So when draw 3D, we just do it dot draw 3D. Earth. This the Earth. Okay, so then in regular Earth, we need the draw 3D as well. So just draw 3D bloom, and then just draw 3D. It's just boom, just 3D, just boom, just done, just go, just boom, just boom. How many days is it? It's 3. Count them 1, 2, 3D. So that didn't work. Are we getting to this line? We're not in debug build, are we? Are we calling the function? So we're doing scene. Yeah, then we're doing earth.draw3D. Maybe the sizes are wrong. So if we just do nothing, none of these, and we just do draw 3D, probably we won't see anything. I don't know. No, we do see it. Well, so there's the Earth. I mean, even this is cool. Like that was essentially the original plan. Very close to that. So the question is why? I think we have to clear the depth buffer. Well, let's try with just pre-bloom and then just the earth. The thing is, I think these filled up the depth buffer. So let's see if my homie is back, Chat GPT. Say similar to this in Kotlin. How do I clear the depth buffer? I think we just want to clear the. Okay, so that. Oh, you know, it's like the blend mode. I think that could be it. Cool though. There's the Earth and the galaxy. But that would have all been possible with one render target. But this would not be possible with one render target. Or whoops. So I want to then disable the blend, not set alpha, disable graphics renderer, graphics.blend disable. And we should see like a faint little halo unless we're missing something. No, I can see the little halo. So I mean, I would just do this like another few times. So like maybe 8 of them. And then the other little thing I would do here, I'm not gonna even make it spin. I'm like ready to put a knife in the Android project for now. We're doing mixed platform development, but in the Earth model data strip, like in the bloom shaped buffer, I think it'll be easy to make it look better if we just say dot color dot red equals like 0.75 and dot color dot green, like red is 6.5 or 7.12 and green is 7.35 or something. F. And then we do something like dot color dot alpha equals 0.75f. We should kind of blew it up a little bit. No, that didn't. It's hard to tell. So if I just make these 0 and 0, it should just be a red glow if the color is working. Or no, I'm sorry. It would be red, green, and blue. We had blue at 1.0. Yeah, okay, so the color did work. That color made a difference. I think we just didn't pick lower enough numbers, like the other thing we could do with the Android app is try to get the sizes of those textures bigger, and we won't have to do this many blurs. But I'm pretty content with that for the Android app. That was really, if we go back to the goal, we say, you know, for this, you know, a D plus or something, and then as a note or manager's note, the developer took longer than expected to complete this task. You know, please leave a note for the CEO. And really, I'd increase my grade here. I'd make it like a B. Yeah, we can even have like a C plus here. Yeah, even B minus. I mean, it works. Then let's go ahead and commit that to the repo. CD, boom, git, add, all, git, commit. We have a multi-stage or multi-phase rendering pipeline. This is Kotlin. Push. So that's cool. The next thing, I don't want to go like too far off the deep end with Kotlin. Like, well, so we could go back to iOS or go a little deeper with Kotlin. But overall, I'm thrilled to see that. So I'll get them running side by side again just to get that side by side. I wouldn't mind adding a couple other states to the iOS one, or getting the resolution of those blur targets down. But there's another more insidious problem, which is yeah, I mean the iOS one is cooler. If we've done more with it, like this 3D. I'm gonna try the glasses again. Oh, you know, it's funny because, oh yeah, and it really works. Wow. Yeah, I totally see that popping out. Alright, so what I want to do to finish up this spat of work is we don't have any lighting right now. So we actually need the lighting. And there's several forms of lighting to do. And I'm just gonna leave this running over here in the side so we can like remember for the video that we got that Android running. Like we got that. It would be like, you know, what is, write an example of Kotlin code that pulls data from JSON and parses it and prints that. But I think this would actually end up being easier. Like I don't even want to do it, but I don't think I would have trouble with it. This is cooler, so I'm all about the cool sauce. Oh, whoops, shoot, I lost my my little reference point. There we go, there's the reference. Oh. All right, so yeah, just banging out, banging forward with the shkabiz whiz. I want to get all the states stereoscopized, all the 3D states that we have. Then I would be happy to call it a day. Because this is actually going to be kind of annoying, but some of coding is just that. It's just, let's do something annoying. And this is going to turn messy. Not shape though, just sprite. Like I really, to see like a solid colored shape pop out of the screen and be like, ooh, that's like popping out, is a little less interesting. The one I want to do is Vertex 3D colored. Vertex 3D colors. Not white. There's another 3D mode called just white. I don't want to do that one. So we do have all the lighting with and without colored too. Then I just want to find the stereo, the way we named it. I think we need another type. So we have Vertex 3D stereoscopic and Vertex 3D colors. We need the combination of these two. Vertex 3D colors stereoscopic. Like so. Like so. Then we go all the way down here into the mud. And we pass in this. Then I want to find the stereoscopic ones again. So this is going to be colored stereoscopic left 3D, colored stereoscopic left 3D, blah blah blah. Then for left, we'll just do this. We're already passing the colors. Oh, I'm sorry. So this should be node. Oh, we have colored, colored, colored. And then left, we only have red. We might want to make sure, because I could be wearing those 3D glasses backwards. What do stereoscopic 3D glasses usually look like? So yeah, the red, it looks like they have both, red on the left and red on the right. Looks like it's usually either or. So in this example image, we have red on the left. What does ours look like? Whatever it looks like, it's gone right now because the simulator is bugged. But anyway, we already tested it and it worked. Thing is, I don't want to replicate wrong work like 20 times, so I'm a little concerned. Anyway, I'm just gonna copy these and say also stereoscopic right. Stereoscopic right. And stereoscopic right. Then just make sure and write we're doing minus equals shift 1. And then left we're doing plus equals shift 0. So when left, we're doing plus equals shift 0, and right we're doing minus equals shift 1. Kind of arbitrary, but we want to always be consistent. And then I just want to confirm the colors again. I'm almost sure that we said left is red in our scenario. Let's look at it. So let's look at what we look like compared to what these look like. And it should really be the same. So it's not. We actually are the opposite with red on the left or blue on the left. So we want to change that first. Maybe we should rename it to blue and red. No, it's funny because I don't think that's the right way to name it. Because it doesn't always have to be blue, like it's blue and green. So there's a bit of a question mark there. Oh wait, these are the ones we just added. So I did this earlier, I switched the two, and I'm switching them back because maybe I switched the these directions as well. So that looks like this picture here now with blue on the right. Let me see if it works with the glasses. I think it works both ways. So I mean this works great too. I mean it seems like it works better, but that's probably just a false like confirmation bias. Yeah, it's pretty cool. With honestly, that background is not the best background for stereoscopic 3D. But yeah, so in right, we're only taking the red channel. What? It seems wrong. Like why we're minusing. Yeah, the one we call right is really left. Shoot. So I really prefer to rename these to red and blue, or red and green. It's blue. So if you look at the glasses, it's red and blue. So I'm gonna name it like that. Everything that is stereoscopic right is for us going to be stereoscopic red. Everything that is stereoscopic left is going to be stereoscopic blue. Stereoscopic blue. And everything that is stereoscopic left like that is going to be stereoscopic blue. Everything that is stereoscopic right like that is going to be stereoscopic red. And I just want to make sure too, if that happens, that we're doing the real right thing with the render before we get too committed to finagling all this stuff. So it's in where? In metal engine. All right, so if I comment out red, it should just be blue. So something's wrong. See, that's exactly what I was thinking. That there's some wrong thought floating around. So in stereoscopic blue, I comment out red here, I think I missed the closing brace. Are they all backwards? Because it seems like we're only drawing red, and here we say we're not drawing red. So I'm just a little confused. So in the actual sprite node, the one we call blue has red set to 0. Maybe we're loading them reversed? No. Maybe they're linked up in reverse here? No. Am I just thinking something through wrong somehow? I'm a little confused. So this one's called blue. And we can see we're using blue and green with red set to 0. This one's called red. We're using red with blue and green set to 0. These things link up to what they're named here. Alright, so we gotta really simplify this thing. So like in Earth, well, we just do a regular render. Let's do stereoscopic red in regular draw 3D. And we'll go with the stereo buffer. That's working fine. So this, we said red, right? Stereoscopic red, and then let's say stereoscopic blue. That seems correct. This engine code gets a bit hairy. Let's see, so when we use storage texture stereoscopic red, Oops. So this is all like just the bloom stuff. Or no, this isn't the bloom. This is, what is this? So here we're calling them 3D right and left. Oh gosh, why are they, these are changing. So like, that shouldn't swap. I mean, it's working. I mean, I don't even really know what I'm driving at here, but it's funny, you can see the edges kind of veering and veering back. So 3D right is red. So everything that says right should say 3D red. And then here 3D left is 3D blue. 3D blue. So if we don't do any of this, red, it would be blue, right? It is. I don't understand how it changed back. I'm a little confused. But this all makes more sense now. And then if we do enable red, it is red. Yeah, it all makes sense now. It almost feels insane because I don't think we changed anything. But I might be just going loopy. Anyway, let's jump into the file. And we're just doing sprite node colored now. So stereoscopic blue means, this is a lot more clear what it means. It means these are 0. And stereoscopic red means these are 0. And I think that's it. Then we just need to kind of do a lot of copy paste and rename. And there's more after these, but I think that bit of confusion we just got over was an important bit of confusion. So we go into modal, and then all these. So I'm just gonna open text edit. So whenever it says colored, it's colored. Stereoscopic red. Maybe we don't need all the blending types. I can always remove it later. It's not gonna hurt to put extra stuff there. But then anyway, we want to also replace red with blue. What order did we go before in red and blue? Oh, see, I already had these. There they are, blue then red. So it doesn't really matter so much. But I think I want to get rid of these and anything associated with them. Fine. So we don't have a bunch of these to do. There's just the few. So colored is going to be colored stereoscopic red. And then red is going to be blue. Then these just become node becomes ignoring case node colored. Then node underscore becomes node underscore colored underscore. And they can go right after their, uh-oh. Uh-oh. Oh, it's colo anything where it says this. So it's because the case insensitive find and replace. So that should just be colored. And just see if it still compiles. It does. One of these should have the word stereoscopic in it. Alright, there it is. There's red and there's blue. So I'm gonna do this. So everything that says node stereoscopic, we'll just say node colored stereoscopic. What's the issue here? Sprite node color. So I think it's the case again. Somehow it became a little s. And we just need to build these states. Doesn't matter where, we'll just do it there. See if we crash. We don't. Then let's jump back to the Earth. Oh no, so then we gotta go into graphics. So all these, and we want to be like making sure we're not talking about like case insensitive. And then these are node colored stereoscopic. And then we won't have those states yet. So we can do the same find and replace here. Can we build? Then into the Earth. Sprite instance. Now where do we want to be? In the Earth, the data strip. So I think we have to build the colored one. So we're gonna call it colored stereoscopic. So this part is much cleaner in Swift. Colored stereoscopic. Then we need the RGBA and then the shift. And then this is also color conforming. So we can mark it as color conforming. That's it. So then we'll make a stereo colored triangle buffer. And then there's like one little big task here, which is not big, but like big enough to be alarming. Is to just fill up that buffer. And these are now colored stereoscopic and colored stereoscopic, and then we just need like red. And I'm fine to put random values. Let's make them like pastel, so they're not too dark. These are always too dark. Blue, and then the alpha can just be 1. Don't really need to test alpha to make sure alpha works. And just build again, see if it builds again. Oh, so in Draw 3D, we gotta go back to fixing that, but who cares for now? We can put the nightlight buffer back in. Yeah, let's just leave it like it was for now. Who cares? But yeah, so in here, we just want to swap to that other colored buffer. Instead of this buffer, we'll use the colored one. And we don't have long left, which is good. So we're getting pooped on here. So for this, we just do colored stereoscopic blue index, blah, blah, blah. And kind of hope that it can just work. And it doesn't. So in Metal, we can look into it and see what's going on. I mean, I clearly see something blue rendering and something red rendering. But not here, so like, oh, you know what? We're just not loading the buffer, that's it. So we just have to load that buffer. But there might be some other issue too. Like there's a lot of weird stuff lining up. Yeah. So that's sweeter than shit. So I took a screenshot of that. Awesome. Awesome. Look at that. Whoa, man. That's like friggin' Trip City. But all that it is the colored versus non-colored. Where is it? in Earth itself, I think, yeah. So right here, this is our colored one. Oh no, I'm in regular draw 3D. That's the wrong function. We can go back to nightlight there, I think, even though I just said we're not going to do that. We can cause a different kind of problem this way. Yeah. So there's kind of like this little patchwork thing that you see where, but the overall stereoscoping, it works, but it looks a little bit funny. It would, this is a good pipeline state to have for coloring by vertex. Even though it seems like barely anything. It's good to have. So I'm gonna zip the project up here and say we have colored stereoscopic colored, stereoscopic colored, and then make a commit to the repo just in case something goes haywire in our next spat. And we should be able to identify some problem. All right, let's go back in here. I don't think we need any new vertex types and stuff. We're just going to be doing lights now. And luckily, I didn't make like a billion kinds of lights. Although we might want like a spotlight or something too. This is where like you might want to use a technology such as Unity, where this kind of stuff has already just been done. But the thing is, you don't know where it is. It's faster to build it than to look up where everything is. Because you can't use it unless you built it. So there's so many Unity games that are like stuck on day one. So now it's time for diffuse. Don't we have diffused colored too? Yeah, we do. So the nightlight one is gonna get crazy. I don't know if we're gonna get to that. Whoops. I might be ready to call it after we do diffuse or Fong. Maybe I'll do all of them. It would be nice to automate this process. But I think it's best to do it just one at a time. And maybe we'll just have a process. We'll first move it to the bottom of the file. And then we'll stereoscopize it. So we have first stereoscopic blue, then stereoscopic red. Diffuse, stereoscopic red, stereoscopic red. But we're going to start with blue. Stereoscopic blue, blue. So the exact vertex type we need. We have, okay, we need more. We do need much more, yeah, shoot. We have in-out diffuse colors. Oh no, these are just like internal types. So it's not like an external type. We do need one more though, don't we? We do need another one. And that's colors. We don't need with colors yet. We need without colors. Okay, so no, not on the in-out. No, we don't need another in-out. We need another... one of these. So vertex 3D diffuse. We need vertex 3 diffuse stereoscopic. And that just gets our red and blue shift. And then these are just replaced with vertex 3D diffuse stereoscopic. And these are very similar to like the other states. So in blue, it's this format, position 0 plus equals blue. So I think that's it. So there's blue, and then we need red, which is just the same thing. So it goes from blue, whoops, from blue to red, blue to red, and in blue, we don't have a blue, and in red, we only have a red. And in red, hold on, which order do we go? Let's look at it to make sure we had the right side again. So it's red on the left, and in the Google thing, yes, it's red on the left. So red is position 0 minus shift 1. So that's the red way. That's the red way. I don't know if it would tell us if we had an error or not. Probably just let us keep going with our error. but yeah. So anyway, so what we need is, and this gets a little bit less hectic because I do not make for all the blending types with light, because it doesn't make sense like in any way to have all the blending types with light. You just need no blending and light. So this might be why it's a little bit hard to find, but there they are. Oh, that's shape node. We want sprite node, not shape node. And we could end up wanting shape, just color in 3D too, but yeah, we're not doing that now. That's like overkill, but we're just working up to. Anyway, so diffuse becomes diffuse stereoscopic red. And then red becomes blue. Red becomes blue. And then we load these somewhere here. Let's do that. Diffuse becomes diffuse blue. But we got to be very careful about the case. And then diffuse underscore becomes diffuse underscore blue underscore. Like so. Oh, yeah, we missed the word stereoscopic. I think that's it. Stereoscopic. Did we do red and blue? Stereoscopic blue, stereoscopic blue. And then here it should be a stereoscopic blue. Stereoscopic blue. And then diffuse blue becomes diffuse red. Oh yeah, no, it's stereoscopic blue becomes stereoscopic red. Stereoscopic blue, stereoscopic red. And then just big blue becomes big red. Let's see if it crashes. It does crash. So we don't have anything named that. So they're named a little tiny bit different. I'm not gonna be anal about the names in this case. I'm just gonna paste in the right ones. These will never touch again. If I had more time, I would be anal about the names. The only thing is, it looks like that name that crashed didn't change. No, you know, they should be fixed. Let's just name them like this, but then the other ones are going to be named wrong too. Yeah, so in some it's diffuse 3D. This is diffuse blue vertex. That one was named right. Diffuse blue fragment, then red vertex, and then red fragment. Let's see if it can compile now and run. It does. Oh, it must have just been when I was pasting those in, I did something wrong or incorrect, yeah. But anyway. Here's diffuse. No, I think I copied the wrong thing. These are the ones I want. Add the pipeline states. Interestingly, we have colored right there too. We could build the colored one here while we rename everything. But no, I don't think we want to do that. So we just need, let's get rid of the colored one. So diffuse. Becomes diffuse. I should copy one of the stereoscopic ones, stereoscopic red. Diffuse stereoscopic red. I want to go next to this guy. Whoops, I think, oh, nope, nope. Oh. Alright, then we need to replace red, big red, with big blue. But there is no like other thing here. So there's those, these. And we just need these two to be built up top. Maybe right next to the other one. And then let's see if it builds. Then in graphics, so even here we can replace the different places all at once. So we're gonna need that. And then the place where we use this, which is here. Yeah, so there's not 4 for this, like there's just 2 right and left, so that makes it a bit easier. So diffuse becomes diffuse. You can find one of the stereoscopic ones to copy. Diffuse stereoscopic red. And then we have red become blue. And then we can get it all on our clipboard at once. And then just find diffuse. There it is. There it is there. We can fix the spacing later. Not shape, but sprite. So somewhere, there it is. Diffuse no blending. Then we got the stereoscopic blue and red. And we should be able to build. Then we need to do something basic. Which is take something like this and replace it with the lighted version. So we now want a lighted, oh, this is colored. So we just want lighted stereoscopic. So there's no RGBA, there's just boom. So this is not color conforming, it's stereoscopic conforming. So there it is, lighted stereoscopic. So if we go back into the data strip, we need another one, and there's going to be one last one. So there's stereo. What we want is stereo lighted or something. Yeah, stereo lighted. Which takes these types of things. Let's add this here, but then we're gonna need to load it too. So stereo lighted, 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 lighted. Lighted stereoscopic, and then lighted stereoscopic. Then we just put in the normals too, X, Y, Z, and the normals here, X, Y, Z. And we can do the same load sort of thing, lighted triangle buffer. Then in draw 3D stereoscopic, we really want it to be more like the other one. Oh, so now for this one, we don't want to use these uniforms. We want the Phong fragment, or I'm sorry, the diffuse fragment. Uniforms, diffuse fragment. Alright. Then essentially we can copy our nightlight buffer stuff from here and put it here. And this one we shouldn't have the night intensity, no. No, we did something wrong. Stereo lighted triangle. Oh, it's uniforms lights vertex, I think, yeah. Anyway, so here we want to go back to the nightlight buffer. That's what we said before, the nightlight buffer. And we're already using that state. And these are going to be diffuse stereoscopic. Blue, is this one blue? Diffuse stereoscopic blue. Another one, diffuse stereoscopic red. So we're using the wrong something. So this is not this. This is, we're wanting to use we want the set dirty on the render, but just on the right buffer. And then same for the other guy. Oh no, there is no other guy. So that's it. I mean, there's now the light on the earth. Not the night light, but the diffuse light. Let me see if it works. I'm sure it's going to. I mean, I can kind of see that it does. It's a little bit weird. But yeah, that it works. I can see the 3D. Alright, I'm only going to do one more, which is going to be the colored diffuse. Well, I'll see how I feel, but I'm not too interested in this right now. So all these we just need to replace with, if it says diffuse stereoscopic, diffuse colored stereoscopic. And we're gonna need a new vertex type. So this vertex type, diffuse stereoscopic. Do I call it colors or colored? I call it colored, but here I call it colors. Fine, I don't care. So it's gonna be like the same sort of thing. Diffuse colors, stereoscopic, and it gets shift. So in here, this thing is replaced by new fish. And this should be a little less work. So this is going to be in out diffuse colors. And all we're going to do differently is pass the colors. So out dot color equals that. And the other one gets the same thing, and out diffuse colors. And then into the second one also comes the colors. And out diffuse colors. And then the same thing. Out dot color. Out dot color. And what we do is times in dot color blah. So here it's times in dot color 0. Is it? Yeah, it is red on the left and blue on the right. Red on the left, blue on the right. Yep. Yep, yep. So here is times in dot color. I'm not gonna do alpha because it doesn't make any sense to change the alpha color for diffuse lighting. Just slow it down. But yeah, I don't think. Yeah, we need like a new primitive type. Lighted stereoscopic. No, we have. So we need one other primitive type, which is lighted colored stereoscopic. Lighted colored stereoscopic vertex. Color conforming, stereoscopic conforming, with the shift red and shift blue at the end. And we gotta make sure this matches. So it's X, Y, Z, normal, 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 color, color, color. Oh no, shoot. So that I copied the wrong one. That wasn't the right one. We want the sprite one. Yeah, sprite 3D. So actually this is like the final boss. There's no more after this. There it is. There it is. And then we get shift red and shift blue. So each vertex gets all that stuff. And the order position, texture, normal, color. Oh no, that isn't the right one. Oh no, we're not looking at the right thing. So the vertex itself is that format. I'm almost sure we have the same format in the other file. So it's X, Y, Z, UV, normal, RGBA, and then shift, yeah. So we could add that to our, and we're not gonna need new ones for the other forms of light. So like this is gonna be the end of the data part of it. It's just more states after that. So this stereo lighted colored. So we'll add it right here. You see, like, the more of this junk we add, it doesn't really slow anything down. Like, the thing is pretty darn fast. It doesn't see the other vertex. Oh, so this one is named wrong. We want this to be named instead with the word vertex at the end. Then we want to use this one. And we just put this random RGBA. And we'll reload. Same business. But we did it kind of in backwards order. So the pipeline states aren't there. But it's not crashing, so that's good. Yeah. I was gonna say, I kind of want to zip it up. I'm just gonna zip it up in case something goes haywire. But now, as we have these functions, we just need the colored versions of the same. So I'm just gonna be copying all this junk. I want to do it all at once. And then to actually get this thing, the declaration, there they both are. I just want to take a little peek in the vertex or the shader program just to make sure we got it named right. So the word colored before stereoscopic. So that becomes that. And then the big stereoscopic becomes colored stereoscopic big. I think that's it. There's diffuse colored. I'm just gonna have two of them. I don't understand. Oh yeah, it is. It's the vertex and the fragment. Alright, then let's find a place where this one gets loaded. Right there. And we want to load these four. Let me find this thing again. Okay, I just have them spaced out funny. Let's see if it doesn't crash. Make sure it doesn't crash. No, it doesn't. All right. then we just have two pipeline states. You go right there, and then exactly where we have this, we can park these two mamma jammas. Oh, why did it geez, you know, this is not the right thing. Nothing crashes, right? Okay. So somewhere there's diffused colored indexed, which is right here. Yeah, somewhere I just lost it. So colored becomes colored stereoscopic red. Let's see if that works or anything is typed wrong. It's not. And then this red becomes blue. So there's diffuse colored, and boom, we got that. And we just gotta go into the graphics. So we can just plop in those. Might as well fix the spacing now. Don't spend too much time on that because we can fix it all with like a couple tabs later. But where we have diffuse stereoscopic, we just need diffuse colored stereoscopic. That's it. And we gotta find where we parked it. And we just gotta add the states. States right there. Make sure it can compile. It can. Alright, so then in the actual data strip itself, when we do this draw 3D stereoscopic, we just need the other buffer let's comment all this out. So this is now lighted colored triangle buffer. We should be able to get maybe some kind of trippy effect or crash going on if we just run it. Yeah, there's our crazy trippy effect. I'm screenshotting that a couple times. That is wacky. All right, then in the earth itself, I think I just put the word colored. Colored. That's it. So now they got all the little colors on each individual node, and yeah, I'm looking at it with the glasses. These ones, these colored ones where I just kind of randomly patchwork it are a little weird, but it works. I mean, I can see it popping out in 3D. I mean, with the lighting, with just the night light like that, like it's not going to be completely copacetic. So what I want to do is terminate this process, but I want to finish on a good note. So I'm going to cd into this git add all git commit -m stereo diffuse colored etc. So the good note that I want to end it on is to effing finish the night light, and I might just delete the Fong light. I honestly don't like it because it uses an exponent. So my plan is going to be to delete the night light. And then I really want to smartly do all this crap. And it started storming here now. Maybe that's a clue that I should stop. But we need the night lights too. We got it up on the repo in case the power goes out. The odds of the power going out is like maybe 1 in 25 from what I've seen. I'm in Florida. In Florida, it storms all the time, so storms are happening all the time. Do I have night light colored? So I think that I can, let me find the night one. So I didn't make night colored. I think that's fine. I don't know if it makes that much sense because the two colors come from two textures. Yeah. It could make sense. Yeah, there should honestly be a nightlight colored and the nightlight stereoscopic colored, but I'm fine to keep it like this with just the one nightlight. So I'm gonna move it to the bottom. Down you go. Okay, good. And it uses Vertex 3D Diffuse. So we could just use Vertex 3D Diffuse stereoscopic. Just want to make sure it still compiles. It does. And then in normal mode, we do have our night lights. Now, important to note, with the 12-hour cutoff, we have to stop at a certain time. So I've got to be confident that this can get done. Otherwise, the video is going to end on a yucky note. But I'm fine to take that risk. So we're going to start with stereoscopic blue. And we just remember that in stereoscopic blue, the position goes plus equals. Stereoscopic blue. Night. Stereoscopic blue. Night. Stereoscopic blue. And this is in-out colors diffuse. Oh, wow. So the in-out night. So. We're a little much in pain right here. So there's our, and I think the uniform type is different too, but we don't really use it for anything. Yeah. Okay, so we do use the night intensity. So we don't use the overshoot right now, but we probably need that if we fine tune it. I'm confused. So the in-out we used for this was just in-out diffuse. Okay, fine. So in-out night is fine too, no issue. Stereoscopic blue. So for blue, yeah, I mean that's we're just beating the dead horse dead, but yeah, it's just putting boom plop right there. Wait, am I in the right one? I'm not in the right one. Right there. Okay, the fragment uniform is the night one. Oh, we have that there. Fragment uniform night. Is that it? Alright, I'm fine to replicate them. I don't even need the whole trick there. I think I can just type the word red. Red. And red. Red. So for red, we don't use these, green and blue. So we can kind of cut out a lot of this. Yeah, why did I lose track of what I'm doing here? So in red, it's minus equals shift 1. In red, it's minus equals shift 1. This is red, this is minus equals shift 1. Alright, then this one is blue, right? Stereoscopic blue. So we don't need red anything, only blue green. So red is just 0. Any bug? So let's go into middle pipeline. What we want is the the functions. Where's the functions? So this is the first place where the word night appears. There it is. So let's actually let's do it all at once. I'm pretty confident in this. So we got those, and we need these. Then we can already match this underscore. So let's say underscore night underscore becomes what? It becomes let's just eyeball it. Underscore night underscore. We'll do blue first. Stereoscopic blue. And we just have this one function here. We don't have like a bunch of them, and just the one pipeline state, for which we're gonna have 2 pipeline states for the night lights in here. So it's now quite literally the word night becomes night, and I can already see that it's trying to overwrite our information there. Night stereoscopic blue. There we go. I just want to make sure I got that copied. Then it's blue big. Big blue becomes big red. And little blue becomes little red. Alright, let's just paste them all in one at a time. There's our knights. Here's our new knights. And when we next use knight, we'll do that. So interestingly, we want to force unwrap these because that's going to tell us if we crashed. I want to try building it real quick. Yeah. So it worked fine, no issue. Just want to know if we have another. So we don't use Gaussian blur colored. Let's get rid of that now. It sounds like do we use this? Yeah. Yeah, that was an oversight to think we needed Gaussian blur colored. We don't. And we don't use these. This is kind of like flying off the wall here. But yeah, we don't need those. Okay, cool. So let's continue to press forward. So where we have sprite node indexed knight bleh, we put our new two boys, boom, get them down there. There we got them. And then let's find this, where this is being created. And we gotta just plop in our new crew. Boom, we got them there. New crew ready to go. And we just override these guys. Boom. Ready to go. And they're all ready to go. They're ready to go. I'm ready to go. We're ready to go. We're ready to go. Going. Ooh, yeah, funny. So we're like so close to the spot, man. Like, but yeah, so let's get there. Let's close it out. Let's end with a bang. So somewhere there's night. I think I can just like put stereoscopic blue and stereoscopic red. Cool. And then we just search up night again. I'm just gonna, stereoscopic blue and stereoscopic red. And then we want like a night stereoscopic blue and stereoscopic red. Why did it say all those different ones? Oh no, I think I copied the wrong thing. Oh, wait. Yeah, no, we want to make sure we're on night. Night S. Are we on red or blue? We're on blue. Blue and then red. And then we got our little moment of danger coming up here. Because we go into where do we go? Stereo lighted. So we want to switch to uniforms night fragment, and we want to use stereo lighted. So we don't want to do the colored one anymore. We want to do lighted as such. Lighted as such. And then we have also the light night intensity becomes the light night intensity. That's it. We should get our weird state when everything's offset wrong. Yeah. Oh, whoa, that one can look wacky, man. Wacko. Crazy, wacky. Trippy, trippo. Cool. I'll pick one of the coolest one of those screenshots. Then Earth itself. Oh, Earth. Not diffused, but now it's night. And we're on the blue one. And this is gonna be night. Stereoscopic red. Hopefully that works. It doesn't. Stereo lighted triangle buffer, sprite 3D lighted stereoscopic vertex. Is there a clue about what might be wrong? No, I want another trippy screenshot though. We're gonna have to use the shader debugger to figure out what's wrong. So both of these are coming up wrong. So here's some garbled junk. I think everything there is right. That's the one we just clicked on. Okay, so clearly the texture coordinates are wrong. There cannot be a texture coordinate of 157. There's our clue. But we're using just stereo lighted triangle buffer, right? Oh, maybe. Maybe, I'm not sure. Because we're using stereo lighted triangle buffer. Was the very first one wrong? I think it was. The very first UV, or is it like the subsequent ones? Jump somewhere like here. It's the second one. So it looks like the first one is correct. Oh, no, why does it have color? So we're looking at something with color in it. So we copied something wrong on the shader, didn't we? Yeah. So these shouldn't be diffuse colored stereoscopic, they should just be diffused stereoscopic. I think that's it. So see, in metal, it could have taken a lot longer to figure that out. But I don't see the night light. So we can again capture it. No, I don't. There should be like a second texture. Okay, I'll bet you it's like it might just be we're not binding that texture. We need to use night buffer. Well, so we need stereo night buffer. Stereo night buffer. 3D lighted stereoscopic vertex. So where we're adding night buffer, we just need another similar night buffer. And we're coming down to the wire. I mean, I think we're gonna be a bit early still, but I don't know what else is gonna come up. Lighted stereoscopic vertex, lighted stereoscopic vertex. So we just should need the red shift and the blue shift, which I guess we're just putting O and O for now. Oops, and this one is stereo night buffer. Oh, I pasted in the wrong spot. Oh no, no, this is. Oh, that is stereo night buffer. No worries, no worries, no worries. And then we already have the light function there like that, so we can just use that. So I'm gonna cut this out and replicate it. And up top here, it's gonna be stereo night buffer, everything. That's it. So we got it with a little bit of time to spare. I'm gonna go ahead and slow the rotation back down. And I wanna make sure that it looks right with the glasses on. I could go in one of two directions. I could add in the Phong lighting, or I could remove the Phong lighting. I think I prefer to remove it, if I'm fully honest. Although I don't notice it going slow. Like it isn't like something where I'm like, oh wow, that's slow. So with about a half hour to go, I wouldn't mind adding the Phong lighting too, just to get like an A+. But yeah, so slowing down the spin, I just had that old number there. There the old boy. And let's look at it with the glasses. So I mean, you can see it with the glasses, but it isn't that impressive. Like the regular Earth honestly looks better than this with the glasses. So it's a bit of a downer, but it works. Like there's Australia right there popping out. So we can turn the bloom on and off. Yeah. So there is night light. And I think with Phong we have the multiple states. So I'm gonna commit this. And I'll just compress it in case something goes weird. Yeah, so there's like a whole half hour to go of this video. If we're going for the full time. Yeah, there's Phong and Phong colored. We just use vertex diffuse colors. Yeah, I'm fine to try to link that up real quick. So I would just cut this all and move it to the bottom. All the Fong stuff. That Fong. So Fong is going to be like Fong. We want stereoscopic blue. Fong stereoscopic blue. Fong stereoscopic blue. Whoops. Fong stereoscopic blue underscore. No, we want to be more careful. We're not being careful enough. So just one at a time. Not Fong colored, but just Fong. And there we'll have it. Then we have vertex 3 diffuse, stereoscopic. And then for blue, or whatever, I'll just put the red one in both slots for now. So there's stereoscopic blue. And I consider this a win in either situation. So I'm happy to claim a victory over the day at this point. But yeah, so then blue will be red underscore. The nightlight was kind of like the final boss. And to say there's no possible way it could get any better at all. So with blue, we have 0 for red. And with red, we have 0 for the other two. And with blue, I believe it's plus equals shift 0. All right, then in metal pipeline, just search for Fong. Yeah, we can't do both at once because of the way they're named. So there's those. There's these. Here's this. We might as well even copy the graphic stuff too. No, let's not. So then for Fong underscore becomes Fong underscore stereoscopic. Fong underscore stereoscopic underscore blue underscore. And Fong big becomes Fong stereoscopic blue. Oh, I put phone, not Fong. Oh, we gotta be real careful with the case so we don't match the case. Cool. Then we just gotta replace blue with red. And we just gotta replace little blue with little red. And they can go like that. And let's find this. Oh shoot, I did shape node indexed instead of sprite node indexed. Is that what I did in the here too in the shader? No, I did sprite. I think we're safe to just replace everything that says shape with sprite. But we gotta be careful with little and little. And then big and big, shape with sprite. Alright, let's find that. Yeah, if we run into any problem, we're just gonna conclude it. And I don't want sympathy. There we go. So we'll plop in new fish. And those will take over. Didn't crash, right? Didn't crash. So then we'll have these two as such. Did I not copy over these? I don't know where these went. Maybe I just forgot those lines. And I pasted these in the wrong place, so you gotta be getting a little careless. It'd be great just to get a home run at the end of all this. Okay, good. We didn't miss anything. Then we just gotta go into graphics where we have Fong. Fong. And we get Fong, and Fong becomes Fong. Stereoscopic blue. And then blue becomes red. And it's good news again that we just have the no lighting, we don't, or the, yeah, no blending. Let's just search for Fong again. So then on the data strip, interestingly, the night one is the one we want for the final version. But for now, we'll do this lighted bleh. So we're just using the wrong state from Earth, I think. But it's a little bit weird because it should have done something more wrong, it feels like. But I'm not sure. Fong. Stereoscopic red, no blending. And then this is going to just be blue, no blending. So that works. I can already see the Fong lighting. I can already see it in 3D. We got to knock out the other one because we're real low on time. I'm just going to quickly compress it in case it boofs. And then I want like 4 or 5 minutes just to high five myself, just to be like, oh boy. Ooh boy. So all these is gonna be colored. This is gonna be Fong colored. And then everything with diffuse stereoscopic is going to be diffused colored stereoscopic, I believe. Yes, that one. And we just also want to say out dot. No, we're missing something. In out Fong colors, that's fine. Out dot. Oops. Fong colors. Out dot color equals verts vid dot colors. Verts vid dot color. Same thing down here. Out dot color and out Fong colors. colors. And then into the other one goes the colors too. In goes the colors. And then it's like times in dot color like 0, or this is 1 times in dot color 1, in dot color 2, and this one is in dot color 0. So good to have. So like these, we can just do a different kind of mass replace, I think. So we'll go like in the other order. And we need these. All those 4. And then these 4. And then these 2 lines too. Is there anything else? Alright, so Fong big becomes Fong colored. Fong colored. And then the shader names underscore Fong underscore becomes under Fong colored underscore. I really hope we don't moof it on this step of it. That would just be anticlimactic. But I'm already celebrating my victory here. Which this isn't really a great celebration. There's Fong colored. So we got 4 new fish. And then we get it fired up. Why don't I see Fong colored? No, I just don't see it. Let's just search for Fong colored. There they are. So there's the new 4. See if it compiles. It doesn't crash. That's good. Good sign. Shoot, we forgot to copy the pipeline states. So we're gonna need to declare the pipeline states. Just put them right there. And then the build functions. There it is. Make sure it all works and runs. Then in graphics, we're really coming down to the wire. So just as we have fawn colored, well, just as we have these two, we need the colored versions. So we'll just plop in these two as well. This time I put red first. Shoot, man, why don't I see the new ones? Oh, that's shape, shit. And now I just jumped to the wrong file. So let me just undo quite a few times. Yeah, so not shape. Can we build right now? Yeah. Fawn colored, stereoscopic red, and fawn colored, stereoscopic blue. I'm going to search up that one again. Just add in these other two states, red and blue. Okay, good. So it sees it. Stereoscopic red, stereoscopic blue. And we just got to jump back to the data strip. And we can now use the colored lighted. And we should be able to mess it up here real quick. Or crash it, perhaps. So let's swap these out. And maybe it's just gonna crash and we won't fix it. Shoot, man. Do we get a message? What happened? So lighted colored triangle buffer. Yeah, so we got to use uniforms fawn fragment. Cool, good enough. I think we're not writing one of the values to it, but I just want to swap back and then get Android up here on screen. and this just produces a strong ending. So this was how the Android app ended. And then on iOS, we have to get back to where we were with Nightlight real quick. So let's go back to Nightlight real quick. So we got to do the stereo night buffer. Stereo night buffer. And then we can just probably undo a few times. We have it commented out, stereo night buffer, and then stereo stop at night buffer. Cool. All right, so let's put it on the iPad. That's it though, man. This is kind of the end of the video. So we accomplished quite a lot with Android. So this is the state of Android. And then this is the state of iPad. And then I just quickly can do another movie of myself and end it. So that's it. Goodbye.